Okay, don't cross the stream. Starting up the streams. I should probably start my bot. That'd be smart to do. Alright, I got the transcoder again. Hold on, I gotta go navigate to where the bot is. And start the bot. There we go. The bot says hi. Alright, this is stream 5, right? Did I have to do the title? Yeah. Stream 5 of my making my own keyboard experience. So today I thought I would work on Flash programming. So I have the data sheet for my microcontroller up here, and reading about how we go about programming the Flash. And we have to do a little delicate dance here because our program is running from Flash. And they even say here that during this sequence, we're in a state where we can't be running from Flash. We'd be pulling the rug out from under us. So we're going to have to run part of our firmware from SRAM, from the data RAM. At least the part that calls the boot code functions to do the Flash programming for us. So I thought maybe just to get started, I would write some functions to read out the contents of the Flash memory. And let's see, I can try out some of these functions. There's one for just getting the, where is it? There's a section of the boot ROM, they call it, where we have the boot ROM version number. Might be interesting to see. But I found out that all of these, hold on. I found out that all of these routines in the boot ROM are provided to us as part of our HAL. So if I go to boot ROM, I think it was. It wasn't boot ROM, so what would it be? Flash? I think I searched for this before. It was ROM data. So in the ROM data module, we have all the functions that are actually in our boot ROM. And some of these, some of these are not functions in the boot ROM. Some of them are like the copyright string, and I think the ROM version number. Just grab the thing from the boot ROM. Yeah. Just grabs it from wherever that version number is stored. But this is convenient. I don't have to make my own function pointers based off of the addresses from the data sheet up here. Right, there's like you'd have to start here to get a pointer to the lookup table to look up a function, and you have to call it with these like arguments here, with these codes, to get the address of these functions. So all that's taken care of for us. So maybe what I start out with today is just getting, I don't know, verify that I know what I'm doing, get the copyright string, get the ROM version number, and print them out. Maybe when we boot. Something easy to start with. Suppose that would be around here, right? Experiment with some boot ROM functions and data. So actually I can just info it directly, right? Boot ROM version. And then call this directly, right? ROM version number. I need to import this guy. And before that, what was the other thing I wanted to do? Copyright string. How about we just print it out as is? Copyright string. All right. So my end objective with the tinkering with the flash is I want my program to have the ability to update itself and also update from one side of the keyboard to the other, since it's a split keyboard. So the program needs to be self-updatable. And like I said before, there's a little dance because we can't just program the flash while we're running from it. We can only program it from functions running in RAM, and there's not enough RAM to match all the flash we might want to program. So one easy thing I'm considering is a two-stage approach where as we're receiving the function, as we're receiving the new program over the USB, we write it to like a scratch area of flash. And then when we're done, we would go back into SRAM and go ping pong between copying stuff from flash into RAM and then going programming another sector from RAM into the flash, and then basically override our own flash image and then force a reboot. So that's actually another thing I wanted to try. So I wanted to make sure I know how to force a reboot, and I was reading that one way to do it is with the watchdog. So it would be ideal to not have to hold down this button and then toggle the hardware reset like that, and then use the UF2 bootloader. Because I have to do this pressing the buttons and it's a little clumsy. I'd like to be able to just type a command and just have it all done by my own code. Okay, so that should have printed out something on the COM port. Yeah, it did not. So what am I missing here? I did build, right? Yeah. So it didn't. The first thing it printed was the first report. I wonder if that's because we haven't gotten into like if it's too early or something. Hold on, let me beep 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 beep. Let me reset it again. Yeah, okay, it's still not being printed out. Beep beep. None of this should matter, right? That's really weird. Guess we can wait until the first report. Hold on. We can do it down here before the first report, because we know we're going to get one. Oh, this seems like a hack. So we'll say like if not initial report. Well, I'll start with true. If initial report. Initial report equals false. We just need to have this flag up here. Let mute initial report equals true. And flash. And open COM12 again. Okay, there we go, it worked. So I wonder why that is that we can't write to the serial port right away. I wonder if it's that we have to be enumerated first before we can actually use the class drivers to write to the endpoints. That might be it. I might have to do something like wait until USB is enumerated. I guess I'll keep this hack until then. So yeah, we're at boot ROM version 3, and we have the copyright string. Beep beep. Wonderful. What do I want to do next? I'd really like to exercise reprogramming a sector of Flash. So a couple things I need to do. I need to figure out how to get part of my code in the RAM, and I don't know what would I do. Just write some arbitrary data in there, and I need something else that will read it back out. Maybe I know what I'll do. On boot, we can print out just like a 16 bytes or something from Flash, from our test area in Flash, and then we'll program it. And then every time we hit reset, or every time we restart, we should see it. Well, I don't want to reprogram it with the same thing then. I guess what I can do is just have a counter or something, like a reset counter. Yeah, I'll have like 1 byte that indicates whether or not we're actually have. Well, let's just have it first. Let's pick a location and we'll just print it out to start with. I need to write a function anyway that like has a nice ASCII hex dump of memory, or I can steal it from another project. I'm trying to think if I've written this before in Rust. I think I have, but I can't remember where. Projects. Let me look at it off screen for a sec. Oh, I just realized all the timestamps on all my directories were reset because I copied from my old drive to my new drive. I'll have to go by the name. Where would I put this? Indeed. I might have done this for, okay, secret project. Well, maybe not so secret, but hold on. Utilities? Okay, looking at some secret project stuff. Nope, not here in secret project stuff. Well, I guess I'll just write it from scratch. Make a new module, call it a dump. In main, declare that module, mod dump. On dump, we'll have a public function, dump, given an address, so base, I guess we'll call it, and length. Actually, I was thinking maybe make it a slice, but actually, why not make it generic and make it a slice? So we'll just call it data. Because we can I make a slice out of a raw pointer? I can, right? Yeah. So this will just be a slice into some bytes. I might also want to know the address. We can just have like a base or something. What type to use here? U32? Okay, and then the idea is to break it up into 16 bytes each. Well, I can have an offset, right? So for I in 0 to data.len, if I mod 16 is equal to 0, then we want to print I just realized to print, we're constructing a line that we're going to call with info, right? So we need a current line. So let mute line equals, I don't know, string new. Okay. And then write into the line %08x, right? Then maybe 2 spaces. I. Make sure that I'm doing this correctly. String comes from alloc string. I thought that write supported writing into a string. It does, but I have to import like something, right? Yeah, you have to pull this in. Core write as underscore. I presume that the stream is working, even though no one's chatting. Okay, that can return results, so I guess unwrap it. All right, and then we're gonna, I think every 8 bytes, we want to have an extra byte. So if I mod 8 equals 0, and I can get rid of that space because we're going to print another space right here. Hey there, Lazy Guru. You're the first one to write in my chat, and it's been 17 minutes. Maybe you're the first one here. I don't know. I can only presume other people are lurking. That's perfectly fine. We're doing some menial Rust coding to dump out data to the serial port right now, so it's not the most interesting stuff. Okay. Definitely lurking. Oh, no, not anymore, Curtis Wright. I have defeated your lurker status. Made you type something. Okay, after that we want a space, and then we're going to print out a byte, right? So colon 02x. If I could type. Data index I. Hey there, Nightshade dude. How are you doing? Unwrap. And that continues to the 16th, offset 16, right? If I wanted to print ASCII also, what would I do here? Well, first things first, let's just handle just the bytes, right? So if we're at the last in the line, that should be a 6. What am I thinking? Then I'm going to write a, and if we get to that, then we're going to print it out, right? So info line. And then repeat this line. This basically cleared the string. Actually, it can do clear, right? Yes. Import that from log. It's probably, this isn't the best code because this is hardwiring it to write to the log. I'll think of a better way to do this later. You're driving for 8+ hours today, though. Wow. Congratulations. You made it, hopefully, to where you're going. And safely, I hope. Consider using an iterator there. Why would I want to do that? Oh, because we have the data byte there. Okay, fine. Sure. Data, might as well turn it into an iter and then enumerate it. And then it's, I forget which what it is. Is it I and then byte, or byte and then I? I guess we'll know by the type. Okay, I got it right. What's it trying to tell me about into iter? It's the equivalent of iter and will not consume the slice. Okay, fine. Fine, I was just trying to help. Just trying to help Rust. Back home? That's great. Okay, I wanted to include that base, so I'll do base plus I. And I think I'm going to want to do that as a U32. Alright. Okay, and then let's, if we get out and we still have something in the line, so if not line dot empty is empty, then we want to print out whatever remainder we have. Okay, let me try that. What should I dump out? How about we dump out the first 16 bytes of the boot ROM, or not 16. Let's go for 32. So back in our main here, we'll just print it out here. So dump. Whoops, hit the wrong key there. Why does it think it's a condition? I don't know. It's not a condition. Is it? Oh, because it's in the module. Okay. Dump. Okay. Data and then base. So this is going to be unsafe, I think. Actually, it might not be unsafe. If I want to say slice from raw parts, right? Isn't that what it is? From raw. Wasn't it from raw parts? Yeah. Oh, it's standard or core pointer from raw parts. Oh, but that's nightly. Okay, so it is sliced from raw parts. Yeah, and then I need to construct the pointer. Okay. It is unsafe though. Okay, so we do have to put this under unsafe. Presumably because we could access that pointer or that slice, and it might be dangerous to do so. So slice from raw parts. Right, so then the data would be, is just 0. This is 0 as const u8. Lane, let's just print out 32 bytes. I thought I provided 2. Oh, the 32 goes outside. Oh no, it goes inside, but then I had a base, which I don't care about, so leave it as 0. And what's it going to tell me? 0 as const. Okay. Suppress that warning. Allow a 0 pointer, because I'm doing this specifically because that's where boot ROM is located. Build that. I'm wondering if I'm going to hit the limit to the buffer for the serial port. I might have to add a larger buffer. Ba-da. Sup, nerds? How's it going, Indorn? Hey, Squared, how are you doing? Okay, yeah, so I hit the buffer limit. Right, it wrote out that many bytes, and then that's all it could do before it hit the buffer limit. I knew I needed to do this eventually, so why not just do it now? I want the logger to first dump it into a circular buffer, and then we'll read from that out when we write to the serial port. I think that's what I want to do. Or what we can do is we can try to write to the serial port, and if it says it would block, then we could write the remainder to a circular buffer that we write to the next time. When would be the next time, though? Might as well do it in the loop that we have, the service USB servicing loop, right? My keyboard still works. See that? All right. At 6 a.m., alarm goes off at 7. You woke up early. My starting the stream is your alarm for Monday, Wednesday, and Friday, and during. Or no, for you it's Tuesday, Thursday, Saturday. Yeah, so let's update the logger to do this. So rather than giving it the serial port, then I'm going to give it access to a circular buffer of some kind. Why not just make a ring buffer? Unless there's one already provided to us. Buffer, maybe? I don't know, ring buffers are kind of fun to write. Okay, let's make a ring buffer. Module main, mod ring buffer. All right. Actually, I can make it so that it's safe by having it have a reader and a writer. That would be kind of fun, right? So we'll have whoever makes a ring buffer can split it into the reader and writer. Okay. Pub struct ring buffer. Okay. So ultimately it needs some memory. So mem. How much though? 1024? That's plenty, right? And then we have the head and we have the tail, right? Okay, and then we're gonna have like the ring buffer writer, which is gonna have access to the ring buffer. Should we have a reference in here? That's plenty, right? Quote, said moments before disaster. Exactly. Please start streaming on an hour later. Okay, I'll try to remember that, endurance. So you want me to start at like, for me, 10 o'clock in the evening would be 7 for you. I think I'm going to have a lifetime for the whole buffer, right? So that's the buffer. If I want interior mutability, I would want to have a ref cell here, right? Actually, I'm just thinking, do I want to make this safe or do I want to just cut to the chase? I should be able to make it safe by the fact that we won't be able to clone the reader and the writer. So, well, I do need a reference count then. Right? I'm thinking, do I make it just a raw pointer? Or, hold on. Or a ref cell. No, I don't know. The whole point is that it doesn't need, we don't need to have a borrow check on this. I do need a reference count because the ring buffer should be destroyed when both the reader and the writer are gone. So can I just do this? Or do that? Let's see if I can get away with this. Then I don't need this lifetime, do I? Because it's the reference count that maintains that lifetime. Okay. Well, I don't know if I'm going down the right path here. I think so. I'm going to have to maybe do some unsafe code to generate the reader and the writer. Let's see if I can do it. Impl ring buffer. We'll have a public function split. Self that generates the reader and writer. All right. Let reader equal this guy. Buffer is, well, we need to make the buffer equals RC new self, right? RC is reference counted. And if it was ARC, it would be atomically reference counted. So the trick here is that this is not atomically reference counted. So, oh, that's going to be a problem. You can't use RC. This is going to lead me to a lot of problems with it telling me it's unsafe to do it, and it really isn't safe. Shoot. I can roll my own atomic. No, I can't. Let me think about this. I need to know when to destroy the ring buffer. Maybe I need arc, but I need that replacement arc. That's what I should just do. I should pull in there. I'll try arc, and we'll see that it doesn't work. This was so much easier in my mind before I started writing it. Reference counted generally means that you increment a counter whenever you have another reference to an object, and then when you let go of that reference, when the reference is destroyed, you decrement the counter, and when the counter reaches 0, you destroy the thing that's being shared by the reference. ASQ wrote something? What? I don't know what you meant by that. Yeah. Thing is, if I do RC, and it's going to be a problem because of I want it to be safe code. So really, I want arc ref cell, right? To do truly safe. Let's just write it like I would if it wasn't embedded. We would do it this way, right? Arc new refs cell new self. Thing is, we're gonna have problems with arc, right? This won't compile anymore. We'll make it compile in a bit, but it won't compile. I'm pretty sure it won't compile. So if we'll just try writing this. Reader, writer. That's the general form of how you would split it, right? This could just take that last remaining reference, right? Writer. Yeah, this is the problem we ran into. There is no arc with this target architecture. So yeah. I guess I should search to see if the Cortex M crate gives us a replacement, because I don't remember if I looked this up before. No, why would it? Because, yeah, it's not a Cortex thing, right? Okay, but there was... Did I bookmark it? There was a crate that I found. It was, Atomics Polyfill Cortex. Okay, maybe it wasn't on librs. No, that's not working. Gosh, my searches aren't very good when I'm streaming. Is it Atomic Polyfill? Ah. Yeah. Yes, and it has support for Thumb v6m. It was Atomic Polyfill. Yeah. Is a polyfill a thing for Atomic? Just cheat and use ring buffer? Do you think ring buffer works on embedded? I can look it up. But it's fun to make our own ring buffer. Oh, it is no standard. Well, what does it depend on? Array init. Huh. Do they rely on atomics? I can look at their code. Array init. I don't know what array init is. Okay. I don't see any use of atomics. Array is polyfill for... Oh, interesting. Making an array from a function being called repeatedly. Wait, what? Mem replace mask? Okay, but where's the check if we blow the ring buffer? Well, I guess this is it, right? I don't see how this would work with multiprocessor. Is this like not safe for multiprocessor? Maybe on init? I'm confused. Okay, DQ. Sample the read pointer and then they advance it. Wait. They rely on this is empty is full, right? I'm having trouble finding things. I don't know. I cannot not finding things. Ah. Alloc ring buffer. How come it's not finding the... I know, I hate looking things up in GitHub. It's part of the trait. I mean, I guess it doesn't have to be atomic. If you read it and it's old, it's fine, right? I'm just gonna do my own thing. What was I looking up? It was atomic polyfill. I mean, I would like to have that and not worry about things as it is. Here it is. 0.1.8. Okay. Let's pull it in. Okay, I can never keep straight. Okay, this one's a dash. Sometimes it's underscore. All right. Still, Rust Analyzer is loading. Should give it a moment. Take a drink while I'm waiting for Rust Analyzer to load. Don't know why people ever use dash in crate names. Maybe it's kind of like file names. Some people prefer dashes. I don't know. Okay. How come it only gives me an option to import it from alloc? I guess I have to be explicit here. Use atomic polyfill. Oh wait, it's only giving me atomics, not arc. It's not an arc replacement. Okay, well, we'll do it ourselves. We'll do our own reference count. Atomic U8 is all we need, right? No, no, no. Back up, back up. I don't want to do this. My mind's just not in it today for doing my own ring buffer. Let's just delete it. And then from main, delete the ring buffer. Delete this. Beep, 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 beep. And we'll just do what you guys are saying. Just pull in ring buffer. Why is the 1.0 crossed out? Does that mean they released it and then they made a mistake and they unreleased it? I guess that's right? They jumped the gun. So it's 0.8. When my mind is in it, I'll reconsider making my own thing. Maybe we can call this my therapy to get away from making my own stuff from scratch. Okay, so what I wanted was to have a ring buffer that is shared between the logger and then this loop here. Inside here, I want to write to the serial port, which means I won't really need to borrow the serial port anymore. I won't need to do all this stuff. Yeah, so we can simplify this greatly. This can just own that serial port. It doesn't need to be put into the state at all. Why did I decide to put the HID in the state? I wasn't going to share that with anything else either. I don't even think I need this state object anymore. I think I can get rid of that. It doesn't take the serial port anymore, but it will need a ring buffer, so log buffer. We'll figure this out in a second. So make a ring buffer for, what's this, like serial ring buffer, right? Data to be written out to the serial port. Let serial buffer equal. Need to learn how to use ring buffer. Mind init? Yeah, I need to init my mind. What does the beep sound mean? It's the Windows ding sound. That's one of the Windows noises. Considering changing it, or maybe just silencing it, you know. Here we go. How we use it. Alloc ring buffer with capacity. Okay. 1024 should be enough for everybody, right? It's probably going to say the type is unknown. Yeah, the type is unknown for now. And can we split it to the reader and writer? That's the question. Thank you, Endorn. Well, why don't I just look up split? They don't have a split. Well, that's a bummer. So how do I share it between a reader and the writer end? Okay, how do I use this thing? Is it read and write? What do I get back from this? What is this type? Alloc ring buffer. What should split do? I want to get the reader and the writer part so I can be owned by one part of the code versus the other, right? The reader should be owned by the code that services the USB serial port, and the writer should be owned by the logger. There's no split here. That's a bummer. So how do I share it? Do I have to do my own sharing? Is the thing at least send and sync? It is. Okay. Is it push and DQ? These are awful names. It should just be read and write. Why do they call it DQ and push? If it's push, they should have pull or pop. If it's DQ, they should have Q. Ugh. And push doesn't return anything? What if... So if it cycles around a capacity is reached, this is horrible. I kind of want to go back and write my own thing then, because this is an ugly interface. I mean, push should return like a result, or it should panic. It shouldn't cycle around if capacity is reached. I don't want that to happen. Or it should like just not push it if it's full. This is no better than me writing it myself because I still have the sharing issue. Okay, I'm changing my mind again. To hell with this ring buffer. I don't like it. We'll just make the ring buffer like we want it to be. So this should be like ring buffer new. Serial buffer reader. Serial buffer writer. Equals ring buffer new and then split. Or I just have new return the reader and the writer, right? Writer. Okay, in here, where we service the USB bus. So, try to, if if we have data in the serial port buffer, try to write some of it. If not serial, slow down and type better. Serial port reader is empty. Just trying to think. I'm going to call serial port reader again to get data out. Why do that and call is empty? Shouldn't I just like in one shot either get data or not? What if I like call it and it just gives me a slice to the data that's remaining, and then I tell it how much? Yeah, why don't I just do it that way? If let sum data equal serial port reader next, then we try to write it. A serial. Yeah, there's no state.serial, right? And there's no borrow, so I don't need any of this stuff. Don't need that. I need to mark the serial port as mutable, though. All right. Right. Yeah, so this is a proper interface. You give it a slice and it tells you how much it wrote if it could, otherwise it's an error, right? So it would be data, just like that. I want to match on that, right? So it's either okay. What does it say the possible errors are? Just would block. Oh, we might get another kind of error out. So what would I do? A panic then? It's a would block. And let it fill this again. Wait, why am I not? Okay, these errors are obscuring the other problems here. So there's going to be like, I'll just wait until I get an error there. If it's okay, it'll be a number of bytes. And here I'll just say serial port reader dot consume or advance bytes. Would block should do nothing. Okay. And then let's see, the logger should get the writer, which it does. Okay. So then I'm kind of programming this backwards, but that's okay. Timer and then writer is a ring buffer writer. Okay, and the idea would be that we don't need to do all this junk. We would get that and yeah, call it the writer. So self dot writer. If it's okay, trying to get my terms straight here. I had written advance, right? Maybe call that pull, and then I can call the other one push. And call this one peak. Sure. I like those names. So this is just push. And we're only gonna need to borrow that. Alright, so I need to store that writer. Get rid of this thing. This is... Alright. New module. Let's do this with gusto. Ring buffer.rs in main declare module ring. I've been ignoring chat. I hope nothing really eureka moments have come forth in chat. Looking for a good one. Thing buff. But I'm on the trail of writing my own now. If that's okay. Okay, pub struct ring buffer. Ring buffer. I think we'll just do it completely unsafe and just prove the safety of it. So how do I make it so that the ring buffer gets destroyed when the reader and the writer go away? I guess I should be able to do that with an RC, right? And we'll just, we know it's single-threaded right now. To satisfy logger, we'll just have to mark this as send and sync. Okay. Actually, if I had a pointer, can I call drop directly? I haven't done this like low-level stuff before. Mem drop disposes of a value. Actually, it would be under pointer, right? Can we like force a drop on a pointer? Drop in place. Executes the destructor of the pointer to value. That's kind of like what I want. Score pointer drop in place, that's what we're looking at, yeah. I don't know if I want to do this with a pointer. I'm having trouble thinking about how these two are going to share ownership of this in a way that I don't have to worry about it later. We don't have arc, but I could bring in the polyfill for the atomic U8, right? And then just do the reference count myself. Then I can implement my own arc, right? Yeah, why don't I do that? We'll make an arc. Asynchronous reference count. Pub struct. Well, it's going to be a generic, right? On some type. Is that how we do it? Or does that mean that we don't know the size? I think it doesn't matter what the thing is as long... Yeah, does it not matter? And then we have to have the counter, so refs. Atomic U. I don't want to use any of these. Hold on. I don't know, 32, since we know we're on a 32-bit architecture. Okay. Can I remember what crate that was in? It's atomic polyfill, right? And I think it was 0.1. Yep. I got it right. Wait a minute. What's this portable atomic? Wait, are we already pulling in a portable... I am. What am I doing? What am I using portable atomic for? Why am I pulling that in? Is that... Did I add that and forget to remove it? Huh. This is used a lot more frequently. I think we don't want this portable atomic. I think I pulled that in briefly and forgot to remove it. All right, arc. Okay. Impl. T. Arc. T. Public function new. Object, which is a T. Self. One. Okay, impl. What does it not like about that? Oh, do I have to say this new one? Implement drop for arc. Oh, this needs to be a pointer, right? Const? Trying to think. I guess we're gonna end up using this with ref cell, right? Probably want a non-pointer, non-null. Oh, I see, yeah. Yeah, I haven't done this kind of direct pointer stuff before. But yeah, that's better. So this would be oh, there's probably something to put it into to grab its address, right? To basically want to forget it, right? Was it forget? I can't remember. I want it to dangle so that I can drop it later, right? I guess I can see how arc is actually implemented in standard core. Let's cheat and see how it's actually implemented in the alloc crate. Okay, they have an arc inner T. And who knows why they have the phantom. All right, they have the concept of both strong and weak pointers. Okay, they do just have a T. Oh, interesting. So they use box and they leak the box, so they do move it onto the heap. I guess that makes sense. Yeah. All right, so it's just box, like we were doing before, right? Box leak, box new object. Box leak gives us a mutable pointer, mutable reference to it, right? And then what do they do with this? Oh, they're using that kind of a thing. Self from inner into. Weird. Manually drop might work. Is it a pointer? It's just a T. Oh, the arc inner is itself. Okay, so I missed that part. Right, non-null, and how to... Okay, that has an into? Got it. Okay, so I would just do into. There we go. We're stealing from Rust, the concepts. Okay, the way we drop self is we say, what's it? If refs self dot refs. Oh, and this has to be completely shared, right? So this has to also be let's see how they do it. It has to also be part of that inner. Okay, now I see why they have the inner, because they have the data and they have to also share the pointer itself. Yes. Okay, so we should do the same thing. So that moves... Well, hold on. This inside here, the object is just the T. And then we have the refs moves inside there. Right? And then this becomes an arc inner. Just like that, right? So then this is like this. The box leak new moves out to here. And this is an arc inner. Which has the object in it and the initial reference counter. Okay, I'm getting myself confused with too much going on here, I think. Oh, that has the into here. Hold on, what? box leak. What did I do wrong here? Object references is that. The into should turn it into a non-null. Oh, that's the problem. There. Okay, good. So, right, so to drop it, gotta say if self inner is it, yeah, okay, it's, I have to do as mute, right? Or is it, I forget how to, okay, I don't know how to use these types properly. I'll just see how they use it. Hey there. How do you say your name? PerPsychF107? Can I call you Per? Hey there, Per. You're from Peru? Starting in programming, could I give you some guides? Please, your goal is to create an antivirus. That's a very ambitious goal. I don't know if I could do that. A guide to create an antivirus, would have no idea what to start from. Let's keep it English so that our moderators can understand what you're saying. It's meta? I'm not sure what I'm saying. I'm not sure what you're saying. At some point they got to increment and decrement that counter, right? Yeah, our moderators have to be able to speak the same language that you're writing in. I guess I can just search for strong. Wait, we can just reference it directly? Okay, so I just need to access it, so it's refs. It's the goal, bro, is the translated text. It's an interesting goal. I can't say I've ever met anyone whose goal was to create an antivirus. And by an antivirus, do you mean like a specific virus or just in general? Like entire companies are built around that, making an antivirus. It takes many people. It's not just one person. This is bro. I don't know what you're saying. Okay. I think there's some magic in this inner as a function. Trying to find the inner. You wrote anti-antivirus software for a while? Anti-antivirus. Whoa. That sounds pretty black hat to me. Yeah, I'll probably need to do this, but what is this inner? Maybe it's at the very beginning and I missed it. No? It's somewhere in the middle? There should be like a function inner. There it is. It's as pointer. Interesting. Okay, I'm just gonna look up some more because I don't know this very well. Non-null. What can I do with a non-null? Dangling as uninit ref returns a shared returns a shared references to the value. Is that reference? Does not require that the value has to be initialized. Well, we'll have it initialized. This is just as mute. Turns a unique reference to the value. The value may be initialized. Okay. So it's just unsafe. So yeah, we can guarantee these all, right? So I can just say as mute. Refs dot fetch sub, right? 1, and then we kind of want. I guess I can do ordering relaxed, right? Doesn't really matter. Equals 0. Then we want to drop it, right? So that's self dot inner. What was it? Manual drop or something? Core pointer. I can't remember these things. Manually drop from core mem. Okay. Okay, what's the problem here? It's unsafe. Yes, I know it's unsafe. Now it's not unsafe, because I say it's fine. Ordering probably comes from atomic polyfill. Exactly. Found, oh, it's an actual structure? Oh, do I want to wrap our non-null pointer in a manually drop? Wait, why are you writing your own arc? Because I can't use the one from alloc. Here, I'll show you why. So I'm using the thumb v6m architecture, right? If I look up arc, and we go to alloc arc, it will say in here, under here, pretty far down, right? Beep, beep, beep. Maybe not. Where did it say? Where did we run into this where it said what target support there was? Basically, okay, I can't find it right now, but it boils down to the sync arc implementation depends on the target supporting certain kinds of atomic operations, and the thumb v6m architecture that we're on doesn't support it. So I'm using an atomic polyfill version of atomics, but I can't just say use the arc from the alloc crate, but use the polyfill instead of the missing implementations. So the next best thing is to make our own arc that, and I don't know, it's kind of fun. Why not? Yeah, I'm writing firmware. Yeah. Time to wake up. It's time to wake up, Andorn. I'm learning. I learn quite a bit by doing stuff from scratch sometimes, and I mean, shouldn't we all, at some point, need have this experience where you write something that's sort of been given to you your entire time using a language? Like, just instead of taking it for granted, you just try to see if you can implement it, and then you maybe get a newfound appreciation for what was given to you before. Right? We kind of assumed we had arc. Now we're on a platform where we actually don't have arc, and we sort of have to do our own thing or find an alternative. Okay, so I kind of leapt into this in the deep end. I don't know how to call drop. Okay, manually. So do I want to wrap object in manual drop? Is that the thing? No, I kind of want the entire thing to be that. So would I manually drop this non-null? Or does non-null have something I can call? Okay, we don't need ring buffer. Too many tabs open. Non-null. What can I do with this thing? How do I tell it to drop? Drop in place? Okay, that's what I want. I want drop in place. I want to say self inner drop in place. It's going to tell me I can't do that. Why? Cannot find it. Oh, I have to do it on pointer. Okay, so I have to say, got it. All right. Core or mem drop in place. Well, oh, hold on. I can just say drop in place and we'll pull from mem like that. All right, so I just need to get this into a pointer. Is it as mute? Is that all I need to do? There we go. So to implement clone, for arct, we're going to want to increment the reference count. So self.inner.asMute .refs. I just need to add, right? Can I just directly add 1 to that? No, I have to call something on it. They just do fetch add and not care about the fetch, I guess. Use relaxed ordering, it's fine. I just don't care about what the previous value was. And that should work, right? Clone on a pointer is just, or clone for non-null just probably just gives me another pointer to the same thing. I'm hoping. Are you liking Rust? Seems a bit tedious as a long-time C dev. It's tedious and challenging to write, but you get a nice feeling of satisfaction when you're done because usually the code just works because the compiler sorts out a lot of the bad designs and bugs that you normally would put in as a C++ dev, at least if you're like me. So by the time you get it to compile, it's more likely to run. And then I don't know. It gets really satisfying to once I've written it and once I start refactoring and clean it up, how nice you can get it to look. I just like it. It's got a nice built-in module system, and I know it's a module system is being added to C++. I don't know about C, but it really, really is nice not to have to worry about header stuff. You know what I mean? Header files just suck. Anybody who likes header files, I have to ask you why. Why do you like header files? No other languages, no modern languages have them anymore. Module systems are just so nice. Okay, so do I need to make my arc copyable or am I done? Can I just make my ring buffer use arc? Let's see. Ring buffer or buffer arc. And I'll let the runtime borrow checker. Sure, we can just have it. It's okay. Ref cell it, why not? Well, I might have to make my arc sync and send, right? Which we can verify. Okay, anyway. You see me struggle with my keyboards because it's a newer keyboard. I've only been practicing on it for about 6 months. Okay, core cell. Here's the moment of truth. We want our own arc, and I don't have it because why? Did I not mark it public? I did mark it public, but it's probably just confused, right? So maybe just manually type this. Use my crate arc. Okay, it's good. So ring buffer is going to have the memory, which is just going to be an array of U8. Was I going to make that an argument when I create the ring buffer? I forget what I decided to do there. We don't have this anymore. I do have an argument there. Okay, so can I make a compile time generic then? Hold on. So compile time generic would be something like this, right? And then it would be size as a U size. Size? Is that how you do it? I don't know how this works. This is a newer feature, right? So let me look it up. Rust generic on constant generics. Const generics. Oh, I have to say const something. Okay, got it. There, I did it. This is just going to say there's no method called new. It should say there's no method called new because they didn't make a method. Right, so these have to be propagated, right? Okay. Yeah, okay, now it says there's no new because we don't have one. Let's make one. Impl this. Pub function new. It's going to return a tuple with the reader and the writer. Reader and writer. Constant generics need constant for the size. Yep, I haven't used them before. It's the first time. So let buffer equal arc new ref cell new ring buffer size. Actually, I can just say new, right? I don't even need to do that. It's put it in manually in here. And then, oh, I forgot the head and tail. Actually, why share that? Oh, because they both need it. Yes. Atomic U size. They don't really need to be atomics, right? But might as well. So 0. I guess I could do mem uninitialized. But why not initialize it? Because I don't have to. How do we do that again? Uninitialized. Core mem uninitialized. It's deprecated. Use maybe uninit t. Oh, this is... I don't like this. I need to get used to this. How about we just initialize it for now? Because my brain hurts. My brain hurts. Okay. Oh, right. For these, I have to say atomic, U size, new, that. All right, and then we're returning the reader. Buffer.clone. Buffer is buffer.clone. Well, I can just say reader equals that. And yes, I know I wrote this about an hour ago, but that's okay. Shouldn't have been so eager to delete it and go with someone else's thing. Okay. Cool. Right, we don't need a mutable state anymore, right? At least I don't think I do. We don't need state. This just borrows the HID. I thought we had the reader. Oh, serial... Okay. That's the name of it, serial buffer reader. Yeah, I don't have those names defined yet. Okay, I probably have to declare HID as mutable, right? Probably. Because they're mutating it and all that stuff. Actually, we might not need to. Okay, and then there's no state anymore. Nice. Okay, so I just need to define peek and pull methods. C will never get modules. Initialized integers are not decided to be valid. Yeah, anyway, what's this? You just need to import it. Let's delete all these things that we don't need. For writer. Oh, right, so this has to be generic on the buffer size. How does this work here? Do I have to say the whole thing here? Okay, no. Hold on. What's the problem here? Oh, I have to put it here? And probably do the same thing, right? There and there. What a pain. No, that's not it. So, what's the problem here? Isn't that what I had and it didn't like it? It doesn't like that. Syntax error. Okay. I don't know how the right syntax for this. The whole thing on the impl line, like a normal generic. Okay, I don't understand what I'm doing wrong, but let's try it down here. Is this getting in my way? For now, let's just comment it out. Okay, I don't have the syntax right. Oh, do I have it swapped? Thank you, A squared. So it's like that? Okay, I don't like that syntax, but yeah, it's okay. I don't like it because it's different from the structured declaration. It's like swapped. You know what I mean? Ugh. All right. Oh, I gotta do the same thing down there. All right. Almost done with the pain. So now we're down to we need push, pull, and peek from a ring buffer. Specifically, the writer needs a push, right? Public function write. Borrow self-mutably, and then this is just going to be some slice, right? Of bytes. Data. And I wanted it to return something, right? It wasn't right, it was push. What did I want for that? Oh, I guess I didn't really care. So if I don't care, why don't I just remove that? So much nicer. Is it because I haven't hit save here yet? Okay, so now the logger compiles, and we don't need the USB bus there anymore. Alright, so to get main to compile, I need the reader to have a peek, and that's going to return a slice. It doesn't need to be mutable. And then pull takes a like a bytes, and it does need to mutate self, and it doesn't return anything. Oh. To do. We'll get to it. Oh, right. It was an option. Yeah. I just did that for convenience, so that's, option. Okay. It ends up being exactly like how normal generics work, but you don't see it normally because with generics, it's one token. Yeah, you're probably right. Okay, now we're actually implementing the guts of the ring buffer. So push can do it in, I can just do the lazy approach, do it one byte at a time. So I can say while, self dot buffer dot borrow mute dot, well, we're gonna borrow the, let's just get access to the buffer. Self dot buffer dot borrow mute. Buffer dot oh, I didn't implement deref for this, did I? Yeah. Ooh. This can just be add ref as ref, right? Fetch add. Does that need mutable access? I guess it does not. Wait a minute, shouldn't it need mutable access? Oh, it doesn't. Huh. Okay then. That was unexpected. Wait. Hold on, what's this problem here? Cannot borrow self as mutual as, oh. Because of that. Okay, right. Does push really need to take a mutable reference, or can I hide that away? Conceptually, if you have a reference to the writer, yeah, I guess we should guarantee that you have a mutable reference to it. Okay, so then back here, log has to be mutable. Well, but log isn't mutable. Okay, then I have a problem, right? Unless I put this into a ref cell. No, we own it. Hold on, we own that. Oh, but log, okay, log is called from many different places. So I kind of want interior mutability. Right? Yeah, okay, fine. Interior mutability it is. Either that or make the ring... No, I don't want the ring buffer right to have interior mutability. Oh, good night, Nightshade, dude. 600 is going to come very early tomorrow. Or you have to get up at 0600. Ref cell new writer. So we're back to borrow mute. And we're not using the critical section anymore. Actually, do I need to do this? I don't need that interrupt free anymore. No, we want the interrupt free to guarantee that this doesn't panic, really. Yeah, I want that. Well, hold on. Why can't I just push it into the ring buffer? It already has this ref cell in it. Yeah, why don't I just do that? Okay, so then I'll back up a little bit. No ref cell on the writer. Instead, we'll just get rid of this. I'll just have the ring buffer do a critical section. Because yeah, that makes sense to me. Okay, so then push not mutable.
Good night.
Good night. Same thing with pull. Sounds fun over there? What do you mean? Okay. Yeah, the problem is that this arc doesn't have a deref, so we need to implement that. Why type when you can copy paste? I forget how deref works. Already 10:30, huh? Oh, it's an associated type. Okay. Okay, target equals, what should I be doing here? I see. So it really is a T then, or is it a mute T? Or do I want... Why don't I just look and see how arc is implemented? I mean, deref. That's just T. And yeah, okay, fine. Yes, T. To just cheat and look what they did. They just grabbed it, so just self dot inner dot as ref object unsafe. There we go. Moving on. Self.buffer is an arc ref cell. So what's the type of this? Wait. Why is it going to the borrow mute trait? That's the wrong trait, right? Shouldn't it be ref cell? That's weird. Why did I have to do that? It's like the... Did I not do this deref correctly? It should be like a reference to the ref cell, right? That's weird that I had to do that. They didn't have to do that. Okay, I don't understand why I had to do that. Okay, anyway, I'll just get past it. So we got a mutable reference to the ring buffer. So I can say buffer dot, yeah, I'll just do it the lazy approach. While buffer dot head is not equal to buffer it's the tail dot wrapping well, fetch, I guess, get. How do I just sample it? Load. Dot wrapping add 1 size is not equal to buffer head dot load. Remove the extra argument wrapping at what? Oh, I don't want wrapping add, right? It's, what is it? It would just be +1 and then modulo size, right? Buffer dot mem. Okay, I think what I want to do is load the head and tail first. Mute tail equals that. Let head equal load the head. We're not moving the head, we're just getting it, and then while tail +1 equal the head. Why can't I just add first? So actually what I should do is just say for byte in data. And then I'll say tail equals tail imprint this whole thing right here. And then I'll say if tail equals head, we break. Otherwise, mem tail. Am I doing this backwards? I think I want to... Okay, I want to do this differently, actually. It should, well, actually, I can do it this way. I can say let next equal that. If we're going to collide, then break. Otherwise, the tail equals the byte. And then tail equals next. Like that. Dereference. Mutable? Okay, and then that's it, right? Oh, at the end, we want to store it. Store. Tail. Ordering relaxed. I'm probably getting these orderings wrong, right? Gotta look that stuff up. DRef coercion should have worked there? Yeah, I don't know why it didn't, so let's try again. I think it's getting it from the wrong trait or something. It's getting it from core borrow, where it should be getting it from ref cell. Which is weird. It's probably because there are 2 borrow mutes and it picked the wrong one. Why would it get it from that other trait, though? Is it because maybe my implementation of arc somehow implements borrow or whatever? Anyway, what are these warnings we're getting? Using clone on null pointer terminal, let's copy. Oh, we can just say that? Really? Yeah, because it's just a pointer. Okay, and then what was wrong with logger? Creates a reference immediately dereferenced by the compiler. Wait. I thought I took a slice. Isn't it going to warn me that... Oh, as bytes is a slice. I'm silly. Okay. I do have real legitimate errors here. Okay, it wants me to convert that. That's fine. What's the key combo? That is it. And then uppercase. Snake upper. No. Scream. We went screaming snake case, right? Upper. Do I not have the right plugin for this? Well, I'll just manually put in the underscore. There we go. It is done. Okay. More warnings. Don't need... We're not using... Whoops. I'm not using refcell or mutex anymore. Wait. Pattern binding woodblock is named the same as one of the variants of type USB error. To mention the variant, qualify the path. I need to qualify. Oh, I guess I can import it. There's no use. Qualify it, I guess. Okay, really, I just want to use that. Yeah, exactly. Non-exhaustive pattern. Okay, wait, what? Missing match arm. Can I get the match arm back? I thought I could just have it fill... Why is it giving me the wrong things there? Anyway, oh. There we go. So that's the alternative? I guess I'll just panic. So that's that there was a real error, right? When we want to panic. Okay, so E, I guess. No, we're not really doing anything in a panic handler, so don't really need to do that, but I don't know. All right, do we need to... We just don't use that critical section, but we still want to lock interrupts when we pull right. Actually, we don't need to do that anymore, do we? I can just do that. Don't need to lock interrupts when we're polling. There we go. I messed something up though. What did I mess up? Uh-oh. Messed that up. There we go. Fixed. Another warning. Right, we're not blocking interrupts anymore. Okay, lots of warnings. Definitely not using that. Or maybe that's why, maybe that was hosing it. So what if I get rid of this now? Will that fix it? That's what it was, A squared. I was accidentally using core borrow mute somehow. My editor probably did that to me. Okay, yeah, it wants caps, right? Okay, gotta hit it in a few other places. Field is never used. Oh, because I'm not calling new on it? Methods called new usually return self. Yeah, the real way would be to do new and then a split on it. I guess I can do that. That'll be less confusing to me later. Where is it? Where is ring buffer? Here it is. New split. Okay, and so new just returns self. And there's some stuff, and then there's a pub a function split on self that returns that. Okay, so that's self there. So I can just remove that. This should just be self, right? Okay. What did I do wrong? Oh, shoot, I did that wrong. This should just say self here. Buffer. Oh, no. It's this part, right? It's late. I'm getting confused. There we go. Split takes arc new, ref cell new self. Does that to it. Okay. Okay, getting there, getting rid of all my warnings. It still says it's never... Oh, because reader doesn't... We haven't implemented reader yet. Okay. I think I'll just keep peak simple. Like, rather than reassembly, when it wraps, we'll just go to the end. So, it's the same kind of thing right here, right? We're not going to mutate either of these. We're going to say let length equal, what is it to do min? Oh, autocomplete was about to help me too. But there's like, min. Core compare min. Okay. I'll just say compare min. The minimum of the, actually, it's whether the head is bigger than the tail or not, right? So it would be if tail is greater than head, one way, else another way. If the head, so we're adding on to the, which way is which? I'm advancing the tail when I push, right? So that if the tail is greater than the head, then it's tail minus head. Otherwise, it's wrapped, right? So then it's I want to go size minus head. And then we're going to return, okay, we went an early return, right? If, not there, but here, if head equals tail, then it's none. I know the Clippy's going to suggest a better pattern than this. We'll get to it. It's going to be some... Here's the tricky part, right? It's core mem, or core slice from raw, I think. Or from... Actually, no, I don't need to do this. I can just slice my buffer, so it's some self dot buffer dot from head to, well, then instead of using length here, this should be like end or something. Head to end. And slice that. Okay, it doesn't like that. Why? Can I index? Oh, I forgot to borrow it. Oh, it's just buffer. And this is going to give me a problem, isn't it? It's returning a borrow, right? Can't index into it. Oh, it's buffer dot mem. Yeah, it's not gonna like that. Yeah, I have to actually turn it into a pointer, right? Or as a raw slice. This has to be unsafe. I need to guarantee that it's okay myself manually. So this would be like, forget how we do this. How do we turn, I guess I can start with the slice, but I really need to make a new slice, right? Core slice from raw parts, I think, from pointer range. Can't remember which one it is. From raw parts. Okay, yeah, then just need a pointer to my buffer. Okay, so then I do want the length. Actually, that was the length. I never changed that. Okay, anyway, this I need to put here and then fix it up. I need like the address of... How do I do this? Rust. Get raw pointer to array. Okay, here we go. Oh, just as pointer. Huh. All right. Returns a raw pointer to the slices buffer. That's exactly what I want. Oh, but I want to add to it the head, don't I? Or the, yes, the head. So it's like offset or something. Head. There we go. It didn't like that though because the type is iSize. As iSize, I guess. That's interesting. Is that because usize might be too big? Oh, it's going to tell me there's an easier way to do this. Try as pointer add. There we go. I love Clippy when it helps me out. Oh, it doesn't need to be mutable. That's right. So just borrow that, and it's not mutable. Okay, there's the peak. So we get access to everything, and we say if the head and the tail match. So I don't even need to do this until I get into here. If the head and tail... Oh, wait, I did need to do that there. If the head and the tail match, then we have nothing. Otherwise, we have some data, and it depends on if the tail is greater than the head. If it is, it's between the two. Otherwise, the tail wrapped around, and we just want to go to the current end. Because I don't want to take two slices and glue them together. I have to allocate memory for that. So then the pull is similar to this, only instead of returning it, it's going to advance the tail, right? So I do want to mutate this. This is going to mutate it. I can trust that they give me the correct value for head, or for tail, right? I can trust that they give me the correct value for bytes, and that we won't blow the queue. So I don't need to do this stuff. Okay, so it's really then head equals head plus bytes mod size. And then store it again, which we did down here. Shadow it. All right, that reference isn't going to change, but we do need to borrow it mutably to. Actually, we don't. Atomic doesn't need a mutable. Then I didn't need this either, right? Oh, I did because I'm writing directly into the memory. Okay. Gosh, all this, it's probably not even gonna work, is it? Did your target have threads? Nope. This is an embedded, you're looking at it. I have no operating system. Hey there, Master Agent Miyazaki and Dr. Padawan, hello. Yeah, my program that's running on the keyboard is almost bare metal. It's relying on Cortex-M and other crates from RPRS, and so that sets up just one core of this microcontroller and gives me a minimal runtime, but there's no threading. I'm not even using the other core yet. Okay, so I have no idea if this is going to work or completely crash. Should I just try it? Let me review this. So we make this ring buffer. And we have a reader and the writer end. We give the logger the writer end so that when there's something to log, it's going to push some string into it. push is going to... I just did the lazy approach of 1 byte at a time. So better would be to push in either 1 or 2 blocks, right? But yeah, I'm just being lazy here. 1 byte at a time. This format is string, right? And then the reader is used here to see if we have data, then try to write it to the serial port. If we would block, then don't do anything. But if we did write some number of bytes, then we pull them out of the reader. So peek gives us some slice into the buffer, and pull just advances the head pointer. And here's where we wrap around the ring. Okay. I have a feeling this is just totally not going to work. But I've been surprised before. Okay, so I'm gonna put this into bootloader mode. Oh, I forgot to close my serial port. All right, flash it. There goes nothing. It's blinking. That means it didn't crash. Oh, I'm seeing something. It worked. It actually worked. It's too bad that this doesn't auto wrap. Hey, but look, it's working. Actually, I'm seeing bounces. We'll have to do some debouncing because I'm seeing key bounces. Yeah, it worked. My ring buffer actually worked. So now when we boot it up, we didn't lose any data. It's unfortunate that it's still... this window wraps. I wonder if I can change Putty's configuration to... I have to take it off screen because there's some... I don't want you guys to see all of my configurations. So do I just do change settings? No, I'll just open this again. I want it to open bigger. That's what I wanted to do. Like... the terminal to be more than 80 characters wide. How do I set that? Window? Ah, found it. How about 120 columns? And then save it. It didn't open it. Wait, what? Why can't it open it now? Can it open COM12? Why not? Oh, I forgot to charge my watch today. Okay, there it goes. Look at that. We see a nice dump of the memory at address 0. So, all the way back to the beginning. I never really did get much of the flash stuff done that I intended, but all the way back to the beginning, where was it? I was looking at this manual here, and what should be at the front of boot ROM should be an... Okay, at offset 10, we should see M, capital M, lowercase u, 1, and then that MU1, 3. There we go. So there's the magic sequence that tells us the boot ROM version. Cool. All right. So I can actually dump out more then, right? I could change this to, since I now have a buffer that's 1024 characters. Beep beep. Beep beep. I can change this to, in main. Where do we dump out? Where did I do that? Oh, I did that after the first report here, right? Yeah, so I can dump out 256, right? Why not? Flash. And okay, so we hit our ring buffer limit. It's like, I think I need to double it. Beep beep. So let's do that. Here it is. 2048. Does that use the stack or the heap? let's follow this. Where does our new go? It's gonna put it on the stack, isn't it? Huh. But then the logger is gonna move it to the heap, right? When we do, where is it? This one, right? When it boxes itself, it's gonna end up putting the ring. Oh, wait, no. It's not on the stack. My ring buffer. Arc, right? Right. Arc new boxes the actual object. Sorry, it's always going to be on the heap. Okay, just making sure. So that 2048 bytes is going to be on the heap. And we got plenty of heap. I think I have 64 kilobytes of heap. That's quite enough, right? We only had 264 kilobytes of RAM. I opened the wrong one. There we go. I got a nice 256 bytes of flash out. Okay. Let me check this in. Beep beep. A lot of changes. Let me reload this. Wait, why can't I... What? Dude, I forgot. There we go. It's hitting P instead of B. It was showing me like other source control folders than I wanted to see. Alright, anyway. Git commit. Alright, so the big thing was I added atomic polyfill and implemented my own ring buffer with the atomics from atomic polyfill. Oh, you know what? I thought I would have to implement send and sync, and I didn't. I got away without doing that. I thought for sure that logger would make me is it probably because of this, right? I bet if I remove these, then it would complain about the ring buffer not being sent. Well, I'll get to that in a second. So dump boot ROM and buffer log messages. I'll add larger buffer and add larger ring buffer for, so that's too long, so I'll make that the content, and the summary would be something shorter. Add ring buffer and boot ROM dump. Okay. Use atomic polyfill for atomics. Anything else that changed? Oh, right. I should probably say that the logger now, well, I should say decouple the serial port from the logger by giving the logger the writer part of the ring buffer. I'm hitting the wrong keys. There we go. These are meant to be separate lines. So do that. Now hit Alt Q and it should wrap it. Okay, it didn't wrap it the way I like, but we can fix that. Decouple the serial part from the logger by giving the logger the writer part of the ring buffer and using the reader part when servicing serial port. Wrap that. Okay, that's good enough. Yep, working on my own keyboard. Oh, why doesn't it remember my passphrase? Oh, because I reloaded it? Okay, Control C that. I guess I'll just quit that and from this window where I already have it loaded, run this again. Then I should be able to git push. And it has my key. All right. Burning the midnight oil. It's not midnight yet. It's only 11:08. Hey there, Apollo I. Yeah, so I have some commands, Master Agent Miyazaki. So the project is to develop my own keyboard, and the keyboard that I'm typing on right now is the Korn keyboard. So I had this designed and built for me, the split keyboard, right? It's 38 keys, 36 keys, something like that. And the next level after having a keyboard built for you is to build your own keyboard. So that's what I'm doing. So the design is based off of the KB2040, which is the Adafruit board, which has the RP2040, which is the Raspberry Pi microcontroller. So I kind of like it because the RPRS group, it's a community within the larger Rust community. They have made a lot of libraries, like foundational libraries for this particular microprocessor, or microcontroller, I should say. So I don't have to do bare metal programming, although I wouldn't mind necessarily doing bare metal programming. It would just make this project take a lot longer. I'm struggling as it is doing things like substituting for not having ARC on this particular microprocessor. There is no implementation for a atomic reference count from Rust core. It just doesn't exist for this target yet. So I had to use a polyfill and basically a stripped down version of ARC that I implemented tonight, which might not be completely safe. I'm not sure about this, the instruction ordering here. I should probably test this by having some unit tests. I actually don't know how to set up unit tests right now, but there's one thing after another. I'm mostly hacking right now and probably clean this stuff up later. So our target is this particular architecture, and it turns out this instruction set, there's no built-in Rust atomics other than fetch and store. So there's no like fetch add or compare and exchange and all that. So that leads to a lot of problems like ARC and mutex don't work or don't even compile or aren't even available, and so we're having to substitute things for that. But a lot of the like things that would be really complex and take me a long time to do bare metal are done for me by some of these libraries we're using, like the USB bus. All we need to do is, where is it? Well, we instantiate the bus allocator that comes from our hardware abstraction layer that was built for me. Just give it access to the registers and the clock and stuff like that. And USB-D, there's a generic device driver for USB devices. They just give it the bus, the vendor ID, product ID, and some things. Tell it it's a composite device with interface associated descriptors. Tell it to build, and then all you really need to do is call its poll function, and you're set. So I have associated with that bus human interface device and a serial port so that it acts as a keyboard. Check it out. I can actually hit keys on it. I have Q and I have W. And a serial port right here if I open up PuTTY correctly. So now when I hit the keys, I'm also getting whatever I want to log on my serial port over the USB. So a lot of that came automatic. It's weird. A lot of the more complicated things just came with the libraries I picked up, and some of the things that you might think is simple, like having Arc, I had to do myself because of some of those missing things. Hold on. Why not C and V like Stack Overflow? I thought of that a little bit too late. You're right. I should make it copy and paste. Yeah. Okay, what did I want to do next? Take a drink? It's getting kind of late. I do want to play around with flashing the thing, though. Oh, I know what I want to do first. I was reading from this data sheet that when we program the flash, at the end, you either have to call into the second stage bootloader or call this flash enter command XIP, which says that it configures the serial, I think that's serial interface, I don't know why there's two S's, to generate a serial read command with a 24-bit address every time this execute in place access. So execute in place is how the microprocessor, microcontroller loads instructions from flash over the flash's serial interface. It says it's slow, but widely supported. I want to see how slow it is. So I want to actually call this and see if my code just continues to run. So we should be able to just call that function. I saw it listed in the hardware abstraction layer right here. I think it's this one, right? Flash enter command exit. Yeah, it's the same text, right? So we should be able to call this and see, and it shouldn't hose my keyboard. It might be slower though. I want to do it like right at the beginning. I forgot to have a comment here. Do this first before any alloc. Before any calls, before doing anything else. Okay, let's start over. We need to initialize the heap before we do anything that might allocate memory. Since it's not always obvious, what does and doesn't allocate memory. Let's just initialize the heap as the first thing we do. I apologize for all the typing mistakes. Still getting used to the corn keyboard. Okay, so after that I wanted to experiment with flash access. This puts the interface between the ARM, microcontroller, and the flash into a slower mode that we will need to use later after doing any kind of flash programming. After doing any kind of flash programming that we will need to use later if we want to continue running after doing any kind of flash program, if we wanted to continue running without resetting, that's essentially it. If we want to continue running, oh, sorry about that telephone call. Actually, I need to take this call, so I will be right back. All right, I'm back. Sorry about that. All right, experiment with flash access. Right, so I should be able to just call that function directly. Flash enter command exit. Is it unsafe to call it? It is unsafe. Build. While it's building, put it into bootloader mode. Flash. Okay. That killed it. It's not blinking at all. Alright, so obviously that is not safe to do. Interesting. So I was led to believe that we can call that and we would continue, and we could continue running. Oh, maybe this is only safe to do when we're running from RAM. It says that between the first and last calls, the code must be located in RAM. But that's between those first and last calls, right? Okay, well, I can try to call it from RAM. So to do that, what I understand is I need to locate some of my code there. I would have a section for that. Oh, hold on. Let's make a section. Let's make some code here. Flash experiment. And then I think it's just you say section SRAM, I guess we'll call it. Is it linker section? I can't remember how to do this. Oh, equals. There we go. It's helping me. Okay, so then I can modify our memory here to put it into oh, how would I modify this? Okay, I think I need to go back and read that page that I was looking for. The Cortex MRT page. There it is. API reference is fine. Okay, we specify where flash and RAM are, but how do I place stuff in RAM? Interrupts. Device at X. Extra, and maybe this is it. Okay. I have buffers. Okay, so this is what I would want to do, right? I would want to add... Oh, this is they say insert before text. Would it have another sections thing? Let's just copy this. Let's see what happens. How hard could it be? I wanted to call it, does it always have to start with a dot? Okay, then we'll make this SRAM. Save that. I don't think no load is what I want. I think I just want to do this and put it in RAM. Actually, why am I keeping the S? I don't need the S. So put everything in RAM, right? I can try this and see what happens. Oh, I need to actually call the dang thing. Okay. So that it would be... wherever I put the experiment, this thing. Okay, build that. Okay, so one thing I can do here, I think it's, instead of build, it would be object dump. Is it headers? Or what is it? Sections? Or all? I can't remember the argument. Help. Help it is. If I played around with any teensy microcontrollers, or no Rust libraries for as far as you know, only C libraries. I've done Raspberry Pi Zero, and I did it all in bare metal, and so that's probably what you'd have to do for something like the teensy microcontroller. If there's no crates out there for it, you'd have to do it bare metal. So I'm planning to do some YouTube stuff for that. It's not really suitable to stream because I already finished it all that I wanted to do, but I would make some videos like going over what I did. Maybe it's disassemble all is what I want. Yeah, and I just want to see that it puts it in RAM somewhere. That's doing a lot more than I thought it would do. Can I just tell it to disassemble only parts of stuff? Just disassemble executable sections. Okay, that's what I want. I'm probably misspelling disassemble. Okay, there we go. I don't think that actually put it in RAM. Less is what I want, not more. Search for RAM.
Beep beep. Beep beep.
Search for flash.
Beep beep beep.
Did it optimize it away? I think it optimized it away there.
Beep 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 beep.
How come I can't
Beep
go?
beep.
How come the arrows don't work? It's a J and L.
Beep beep.
J and K. Yeah, okay, it inlined it. I don't want it to inline it. So, what was the way to suppress inline? Inline? No inline or something? Let's look it up.
What? Oh my god.
Inline never. That's what we want. There it is. Look, it put it in RAM. So here's the section, the experiment is in RAM, definitely. Okay, cool. So build that. Flash. It didn't work. It's still hosed. Okay. That didn't work. Bummer. So I wonder why that's not working. My guess is that it's just too slow to work with the peripherals somehow. But if it's running from RAM, we should be... Well, hold on. Where did I put that code? Our data sheet here. I don't know. I don't know why this isn't... Why it wouldn't continue running. I can use the LED to see if it actually does continue executing there, right? So I can move... I know what I can do. I can move the flash experiment down till after we have access to our pins here. And then we can have it borrow the the neopixel. Okay, and then... Only problem is this type is complex. Ah, come on, let me click in there. There we go. If I remember right, the timer goes there. We'll take a watch when I upload it. Oh, the bare metal stuff? Yeah. There's tons of Arduino libraries. Yeah, but are they in Rust? I need to make that generic, right? Oh, right. I need to import all these dang things. Let's get rid of that for a second. Okay, this... I think it's confused. That's confused there. What is the actual type there of the countdown? This thing, countdown timer from RP2040 HAL. Okay, so I bet there's something's already using countdown. Yep. What's using countdown? Okay, so that was accidentally imported then. I think. No, it wasn't. That's used, but for its trait. So if I do that, then I can actually import the real countdown, right? Yeah, there we go. Now the import works. Cool. It's probably telling me I'm not using it. Explicit lifetimes. Oh, it's elided, so I don't need that. Okay. So what, I can just put an underscore there? No, it needs... Can't find it in scope. I thought I brought it into scope. Hold on. Okay, must have undone that by accident. Okay, cool. Now I can set it to like some value just to see that. Let's set it to one color and then enter the flash function and set it to a different color. So I'll set it to red first, and then if we actually get in, we'll set it to green, which would be 0, 255, 0. Mutable. Oh wait, there's a problem here. This stuff is in Flash. Yeah. We can't call anything in Flash after we execute. Well, we should at least be able to confirm that running from RAM works by calling. This should still work. Yeah. Okay. I can actually. This is fine. This is a good test. Build that. And then Flash. ELF contains memory contents for uninitialized memory. Why is that an error? Okay, that's a problem. Did I have that error before and I just didn't notice it? Yeah, okay, I didn't notice that before. It didn't actually build it last time. Why would I have memory contents for uninitialized memory? Are you winning, son? Yes, I'm winning. I am winning. Now you can get all your Cedar libraries to Rust? Is that source level conversion? Just mark it all unsafe. No problem, right? Okay, I think this is the wrong way to do it then, right? It doesn't like that I put some code in RAM. Just to confirm yeah, so it is in bootloader mode. It's just that I can't build the UF2 from it. ELF contains memory contents for uninitialized memory. Hey, let's Google that. Oh, it's been 3 hours? It's been 3 hours. Ha. Someone else has run into this problem. Beep beep. Maybe. Beep beep. Yeah. Looks like the scatter file still uses smaller from Flash, blah, 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 blah. It was supposed to be loaded by debugger. Okay, I don't understand this. It marks unsafe and rust to preserve exact functionality. Yeah. I mean, if you inside of an unsafe block, you can type almost anything in Rust that you could type in C. It's just the syntax is changed around. I think this is the wrong. Oh, you sent the wrong link. Okay. Teensy for RS. There you go. There's the Rust. There's a Rust crate for Teensy. I believe RP2040 boots using pre-installable and load. If the UF2 is compiled linked to use only as primary, nothing is flashed. Oh, don't I have to tell it? Okay, I have to tell it how to load it. It's separate from where it's run from, right? Yeah, okay, I remember this. There was like, what was it? A way to, yeah. A way for me to click in here and then click here, and I can go back to Cortex M and go look at source. Or was it somewhere where they have the linker script? I'm not seeing it now. Is it under Cortex MRT? Yes, link.x.in. Okay, now this is the template for the linker script, I think. So how do they put it in RAM? No load. That's uninit. BSS. How does data get loaded? There we go. At greater than flash. I think that's what I want. Am I going to get into trouble by having two sections within RAM that are loaded after flash? Well, I guess we can find out. But that's the thing I need in my linker script, right? Like there. Let's just see what it does. It overlaps with the vector table. Okay. Maybe I do before .data? No. Actually, I think it needs to be within the data segment in order for it to get copied to RAM. So what if I just put it inside the data segment? What will it do? We can try that. I'm gonna try that. So instead of having this junk, I will just put it in like data dot code. Let's see what it does for that. Okay, can I flash that now? Oh, it did something. Okay, so it turned it red but not green. So I should see where it's what address it's in the disassembly. Beep beep beep. Beep beep. Thunk. Oh, it's still putting it in text segment, right? Still putting it in flash there. That's not good. Beep 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 beep. Yeah, it's still branching to a flash instruction, to a flash address, so that didn't work. I thought because it had this in there that it would load it in RAM, but it is not doing that. Well, I can try to find out what other people have done. RP2040 Rust load code into RAM. We might have to copy the instructions themselves from flash to RAM, right? Second article. Yeah, but this is like loading a whole program into RAM, and then from there loading, having that run and write to flash memory. Yeah, I don't know. This might take me a while to figure out. Hey there, Clayman. Clayman Dev, what happened to Clayman? Did you change your name? Yeah, see, there's no answer to the Stack Overflow question either. The question was too complicated. I might have to punt on this for tonight. So here's our function here, right? Wait, what is it doing here? Oh, this is thunk to jump into RAM. Oh, and here it is. So it is executing out of RAM. Look at that. So it put a launch pad to go into RAM for some reason. Why would it do that? That's weird. This, I remember that this once makes it run in thumb mode. So it's going to go to the top of RAM in thumb mode, and here it is, right? Yeah, see, here's where it's calling the this is where it's turning the LED to red, and there's where it does the oh, it's weird. Why is it going to some kind of thunk? Anyway, it's branching to do the flash enter command thing, and then if it had gotten past that, it would have turned the LED green, but it never got that far. It's obviously red. So it got stuck somewhere, but it probably was executing out of RAM, otherwise it never would have been able to set the LED to green, right? Okay. So it's still this flash enter that's a problem. I don't understand what this is doing. Oh, I see. I think I know what it's doing. It's branching into the boot ROM area for some reason. Yeah, okay. I think I'm getting tired. Can I call something else from the boot RAM just to make sure we're calling the boot RAM correctly? Instead of that, maybe? What else can we call from the boot RAM? boot ROM. Something that's not flash related, I guess. How about we call one of these fast counting things? Return a count of the number of 1 bits in value. Sure, why not? So what do I actually call from here? Pop count 32. Return the number of 1 bits in the value. Let's try it. So info. There are blank 1 bits in something else. Pop count 32 value. Let value equal, I don't know, 42. Ba-da. Ba-da. All right, and then it actually didn't crash that time. But it also didn't print out what I wanted. Oh, it's possible I called it before did I call it before I initialized my ring buffer? Yes. Okay, we need to call this after the ring buffer's initialized. Down like, here is fine. Beep beep. Ba-da. Flash. That didn't actually do anything, did it? Ba-da. There we go. COM12. There are 3 1 bits in 42. Is that right? I should have picked a number I knew. All right. Programmer. 42. Yeah, there are 3 1 bits in 42. Okay. So supposedly this function is in the boot ROM. This pop count 32. And just to verify then, this function is just breaking things for some reason that I haven't figured out yet. Ba-da. Ba-da. Yeah, see, it stays red. It doesn't go to green and it doesn't get out of the loop. I guess I can open the serial port. Yeah, it's dead. It can't talk to me. Of course I can't open the serial port. Hey, Griffing and Chill. Mr. Sir, how are you doing? How was your gaming? You're probably going to bed, so presumably good night. And happy birthday. It's still 9 minutes of your birthday left. I'm trying to figure out how to program the flash on this thing from my own code. Just chillin'? Of course. It's Griffing and Chillin', right? Yeah, I'm having trouble. This function on my microcontroller, it says it here that I should be able to call it. Where does it say that? This one. It configures the flash into a very slow but widely supported mode. But for some reason, we never exit that function. If it were to exit properly and execute from flash, it should have turned the LED green. It didn't. It stayed red, which means that it executed this line, which turned the LED red. And it went into some crash state or panicked or something. I don't know. So this is a problem for me because I'm going to need to either call that or jump to back to the second stage bootloader after I program anything in Flash. So I'm kind of stuck. But yeah, I don't know if you've seen this before, Chris, but I have a. If I comment this out, I can make this code work again for a second. Flash it. So flashing purple means it's working. Look, I have a working 2-key keyboard. It's Q and W. So it's actually a composite USB device. So if I open a serial port, now when I hit the key, you can see the actual key reports over USB. So 20 and 26 are the USB scan codes for Q and W. So I have logging working. The log is connected to the serial port through a ring buffer, which I built today. We're tracking time with a timer. We're reporting the number of scans per second of the keyboard, so it's actually a lot of scans. It turns out every 20 microseconds we scan the keys. I wired up these 2 keys yesterday, and figured out very late that I needed diodes to prevent competition between the columns. We were getting kind of far. Have you checked the errata of the reference document to make sure it isn't a known issue? No, I haven't. That's a good idea. Well, I mean, we could just Google search it and see how other people run into this problem. How about that and crash? No. How about this confused about execute in place function? Blah, 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 blah. As far as I know, uses a buffer and RAM. Okay, how about if I fine-tune the search and say that and RP 2040? Actually, that doesn't really refine it that much, right? Oh, is it that we're executing from the wrong addresses now? Because there are aliases, different aliases to the flash, some that are cached and some that are not. I wonder if it's that we can't actually call into the normal flash addresses in that mode. Error 9, ROM bootloader cannot boot directly into XIP cache as SRAM. No, the cache as SRAM is something else. What was I reading about that? It was where it was listing the kinds of memories that it has. So there's boot ROM at address 0, right? There's SRAM starting at 2 and all zeros. And then there's other on-chip memory. I think this is what they're talking about. There's the cache associated with the execute in place starting at that address. And maybe they're saying that we can't boot directly into this 16 kilobyte region, maybe? I don't know. So what I was thinking about, there are different aliases for flash. The normal, this one, so this execute in place is if we execute from this address, it's translated into a serial flash transfer, right? It's transparent to the master, blah, blah, blah. So it's execute in place. An internal cache remembers the contents. It's correctly configured by the boot ROM and the second flash stage. So maybe I just need to read this closer, right? I don't know. So there's, right, here we go. So there's different aliases of flash. It's a cache operation if you go to that prefix. It's non-cacheable in different ways, bypassing the cache or always updating cache with these. And this is to access the cache directly. So to bypass the cache directly, we would go to 1.3 something, something, something. I'm wondering, what if I change our flash to start at 1.3 instead of 1.0, so we would bypass the cache completely. I wonder if that would make things work. Hey, we can't really destroy this thing, so we can always just experiment and try it out, right? Hey, let's have our flash start at there. The length isn't that big. I don't know what to put instead of that number. What is that? That's 2 megabytes? I don't know. Let's just say we have, actually, no, the length doesn't change, right? That's just an alias bit. So we can leave the length alone. Yeah, what if we try this? Let's make sure it still runs without doing the flash experiment. No, it's completely dead. Okay, that didn't work. Huh. I wonder if it's because the flashing, the program that runs in this when it flashes, it doesn't like this base address. I don't know. Make sure I didn't destroy it. I shouldn't be able to destroy this thing. Yeah, we're back to normal now. I don't know. I'm hoping to like have breakthroughs by guessing things. If the cache is disabled via that bit, then all 4 of the aliases bypass the cache. So it's a significant impact on XIP code execution performance. Okay. So you said there was an errata at the end? Errata, boot ROM. Bootloader cannot boot directly into XIP cache's SRAM. Yeah, okay, I mean, that makes sense. When, say, enable it as a cache, it starts to destroy your program, so you can't boot directly into it, right? See, when they say add code in main SRAM, are they talking about the trick that I did, where you just mark the section lives in data somewhere? Or I wonder if they have a more sophisticated way to load code, to add code in main SRAM. Clocks, GPIO, USB. Okay. Fails to exit reset on a busy USB bus. Huh, I wonder if that'll be a problem later, maybe. Race condition when aborting an XFE DMA stream and immediately starting a new stream. I don't think that applies to me. Okay. Could search the documentation for more references to XIP. Right, there's the aliases into the flash. There, cat peasant. I'm trying to muck with the flash on this microcontroller while it's running. Trying to do dangerous things to this microcontroller. I don't think this applies. Okay, it's cacheable. We know about that. Oh, what was that? Maintenance. Okay. Don't write to the cache while flushing it. You know, I just thought of something. What if that function assumes that you have done the other function calls, right? So they talk about, like, there's a sequence of, where is it? In the boot ROM, right? This right here. They say a typical sequence is this, 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 and when you're done, call that. What if they assume that I have already called these things first, right? So what if I call them before calling that, right? So we're going to call connect internal flash, exit XIP, and then enter command XIP. Let's try that. So what was it again? I don't remember, so I'm going to go look, connect. Okay, we're just going to copy paste because we can. Connect internal flash. And then flash exit XIP. We're going to have to import those symbols, right? Yep. Let's try that. Build that. So we're doing essentially what it says we should do when we erase a flash sector, except we're not actually erasing a flash sector. Actually, maybe I should do this flush cache too. Before that. That I should probably do, yeah. Yeah. So everything but erasing the flash now. My objective is to, like, actually boot correctly, even though we did almost all the steps to erase flash, but not actually erase it. Ba-da. Ba-da. Nope. It is toasted. I could try different colors to see how many steps it got through. So how about we go to blue on step 2? And then exit XIP, because this all should be running from RAM, right? Oh, except for this code is in Flash. Yeah, it's not safe to call that, right? We're not supposed to access Flash when we're in the middle here. Okay, that bums me out that we can't, that this sequence doesn't work. That it crashes somehow. Why would it? I don't know. Okay, the next thing we can try to see if we're actually getting this far, I could actually just erase a sector and write something. And the next time it boots, we would just read it out. Let me think about this. No, but we can't. The whole problem is that this is causing it to crash, so we can't really call it reliably. Or I should say we can't start executing from Flash again like it says we should be able to. I keep coming back to that. That's a problem, right? I don't know what to do. There's this SDK hardware flash library hides these details. Maybe I should take a look at the SDK and look at what that does. It's after midnight though. I really need to go to bed. Oh, is this what we want? Driver code for the Flash. No, it just was in their comment. What does this actually do though? Oh, do we need to disable interrupts? Maybe? I wonder if that's causing problems. What if that's it? What if, it's that I don't have interrupts disabled? SDK. Note that these functions are unsafe if you have two cores concurrently running. We're not doing that. It's unsafe if you have interpandlers or an interrupt vector table in Flash. So you must disable Okay, maybe I can try that. I can try disabling interrupts. I didn't think I actually had interrupts running, but maybe like the timer is using an interrupt? Could that be? Okay, let's try it. So to disable interrupts, it interrupt free, right? And then we get some critical section we don't need. And then we put the code there. Like that. Now interrupt should be blocked, right? And this comes from Cortex M. Okay, try that. Ba-da. Ba-da. No, it's still stuck on red. Yeah, it's never getting out of that call. Let's review what this does. Interrupt free. Disables interrupts. And then makes a critical section and calls our function with it. So interrupts are disabled, but still it's not getting all the way to this line. Or it's getting to this line, it's calling into Flash and then crashing. I feel like I'm missing something, like I'm hosing it some way that I'm just not thinking of. It'll probably occur to me when I wake up in the middle of the night or tomorrow when I'm at work or something. So I should probably table this for now and look at the tests that I have to do. I need to do a little bit of debalancing at one point. I've been avoiding this one, but really I shouldn't. I should break out the CAD tool to start designing, not the PCB. I had that wrong. It's not a circuit board. It's a printed wire board, right? The printed wire board that we're going to mount the switches and the controller on and all that stuff. I need to learn how to design that. This is really a bonus task. I can get by without that. I would just have to, whenever I reprogram the keyboard, I have to use these little buttons on both halves, which would be a pain. It'd be nice to learn how to do this, but I don't necessarily have to do that. So I could either work on the CAD tool next, or I could figure out the link between controllers next. The call to flash exit after which you will see is not optional. The function flash init spy here is folded into that call. Flash is intended to be used to enable XIP following some flash program sequence, so it assumes the calls are paired and doesn't necessarily configure the SSI on its own. Yeah, but aren't I calling connect internal flash? I'm calling that now. Where did you read that though? Maybe there's more information there. Flash init spy? It's folded into that call. Oh, thank you. Move the link over to here. I have lots of tabs. Chris would be proud. Okay. Hmm. Right, that's sort of what I'm doing, right? Yes, CPU locks up. That's exactly what's happening to me. I'm trying to avoid this, by the way, having two of them and then debugging one with the other. That was, yeah, I'm reading through the whole thing to see if there's any other hints here. Yeah, valid program in Flash, which calls into RAM. Then you can run boot stage 2 by doing a watchdog reboot. But that's the thing I don't want to have to do, because I need to get access to Flash again to read the next sector to copy it over. It says the code in the bureau will get you generic slower access to XIP. This isn't exactly true. I have them separate addresses. This is a long thread. Right, this might be happening. Although it should have at least changed the LED. No, I'm not following this anymore. Actually crash the CPU, right? Right, this is what you copied into chat. Stay following flash program predators. Flash chip select this bit bang during flash program so that it stays asserted. Connect, exit. That's exactly the sequence I'm doing, right? Connect, flash exit XIP, flash flush cache, flash enter command XIP. That's exactly the sequence I'm doing. It works perfectly now for them, but not for me. No. This is the code for flash. Okay. Maybe do I need these memory barriers? I wonder if I need those. I mean, I could try adding them. Okay, I'm gonna try that. So, if I remember right, it's I don't remember what it is. I can search Cortex, a Cortex M. Here it is, barrier. Where was it? It was. Beep, 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 beep. How did I find it last time? Cortex M Rust memory barrier, right? Yeah, it was in the ASM. Okay, I know what to find from there. It's an ASM, and then it was DMB. That's what it was. ASM DMB. Let's just fully qualify it. There, we have data memory barriers around all calls there. Ba-da. Ba-da. Nope. No, it doesn't work. Yeah, resetting it. It's just dead on startup because of that. Okay. Hoping to like that it just suddenly works when I get it closer to someone else's code. Yeah, it's failing. Well, it's failing somewhere between here and here. Problem is I can't like do anything observable within this region because I can't call anything that's in Flash. And this is in library code, so it'd be really hard to move it into RAM unless I made the entire program in RAM. Which I guess I could do. There's a mode for that, right? I could load this entire thing into, I could make a RAM only build. I don't know. Keep looking at it, think I'm missing something. Well, I marked it as not inline, right? Inline never. I don't know. ROM functions. ROM table lookup. Let me look at the disassembly of this. Where is that command? Here it is. Experiment. Okay, here it is. So it jumps into this RAM section here. Huh. So branch long to D4 and then E0. D4. Wait a minute, it's jumping back into Flash for that? That's not good. Yeah, those functions can't go in Flash. Wait. I'm confused. Connect. One G. Next. Okay, that's the problem. It's putting these things in Flash. The ROM data functions in Flash. This isn't going to work. Right? Because the moment we, after we execute and we try to call these other functions, we can't be jumping back into Flash to call this stuff. Doesn't it need to be like inlined or something? Hello. John Januskovacs, 1994. Tried text sector. Most times I've seen linker code actual code being stored in text, not seen code before. No, I think this is the problem, is the way we're linking in this module. It's putting it into Flash. But they, like the Flash, I guess this, we can call this trampoline code, the code that jumps into the boot ROM, but it's not jumping directly into the boot ROM. It's looking up functions, and the function lookup code is in the Flash, so we can't use that. I wonder if anyone's ever tested these. These. Has anyone ever tested this stuff? Like, these ROM functions. I wonder if anyone's ever tested them, because I don't think, looking at this disassembly, we can't execute this stuff, right? Or this is executing from Flash, which is going to be disabled. Using installing what are you talking about, John? You using installing RoboArm RoboCar? I don't know what you're talking about. All right, so I think that's the problem. Is this code is just unexecutable. No one's ever tested this stuff. So I got to do it myself then, right? I need to look up the functions and cache the pointers to boot ROM myself in order to call them. I'm disappointed. That deserves like a bug report to this crate, right? I wonder if someone's reported that already. So if I go, let's go look at their, let's look them up. RP 2040 HAL, right? Yeah. 2040 HAL, GitHub. Let's see if they have any issues. They got 23 issues. Take you 5 seconds to test telling the linker to use the text section instead of code, and then get the thought out of your head. Okay, so what did you want me to do? Try the text sector. Most times I've seen linker code, actual code, and it's stored in text, not seen code before. Oh, you mean the section that I made? This one right here? Because, where was it? The link, I closed it. If I follow it to entry, yeah, and then I can get it from here. Cortex MRT link.x.in. Here's their text section, right? And then to get my code into RAM, I had to prefix it with .data, but they have a wildcard here, so that means this gets put into RAM because this code matches the wildcard. I don't think it matters if I put text here or not, because it's just going to match and put it into this section in RAM. Everything going to flash is there, including the text sections that you're talking about, right? So, I mean, that shouldn't have any difference. If that's what you're asking me to do, I can do that really quick. I don't think it's going to make a difference. It'll still...
Let
me completely unplug it to make the LED reset. Yeah, so it still turns red when I plug it in, so it's actually executing that. And looking at the disassembly, pretty sure that it was to be loaded in RAM, right? Experiment. Yeah, so there's this thunk to jump to, for some reason they have this thunk. Oh, I know why. Because it's too far of a jump to jump that far, to jump with a thumb instruction, right? So they have to do a long, this is a way of doing a long jump between the 1 million and 2 million, right? Okay, yeah, that makes sense to me. But here's my code that is making the LED turn red at least. So it executes that at least. And then it gets lost down there.
beep beep.
And I think it's because it's jumping back into ROM, it's jumping back into Flash here to call these functions, right? Well, even that data memory barrier is a jump back into Flash for some reason. D4, right? What's D4? Jumping to 784B. 784B.
Beep beep. Beep 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 beep.
Wait, what?
Beep beep.
This is okay. I just have to keep hitting this button. No, we're never gonna get there. 0007. Really? How about if I go to the name of the function? DMB. DMB. Data memory barrier. That didn't help. Oh, wait.
Beep beep. Beep beep.
There it is. So the data memory barrier is actually a function which does data memory barrier and then returns. And it's in Flash. So we can't even call that. Okay. Wow. Okay, so Rust, you suck. Can't even call these because they are in functions in Flash. We can't call these because they're also in Flash. We have to do this manually. So how much work will it be? They describe here how to access these functions, right? So we start in the boot ROM. There's a pointer to a public function lookup table, right? A 16-bit pointer. And I presume this talks about what to call it with. Let's see. Assuming the 3 bytes starting at the address are MU1, then the 3 half-words starting at address 14 are valid. What if it's... Yeah, it is MU1. Okay, then what do we do? These three values can be used to dynamically locate the other functions. The version byte is informational. Okay, so we get the half-word at 18. Pointer to helper function. ROM table lookup. Okay. And then we get the data table from 16, and we call the function pointed to at 18 with 16, and then the 32-bit code. It corresponds... Okay, so we take the 2 characters and shift 1, 8, and OR with the other one. Ah, got it. So there's a 2-byte code that we pass to the lookup function. Okay, so I got it. So we have to code this in Rust, basically. And we have to put it in RAM. Or we have to call it first and stash those pointers somewhere. I wonder, do they provide those lookup functions here? Not there. Here. No, that sucks. I was hoping they would. I could just call them. Yeah, they don't have them directly in here. This ROM table lookup. I was hoping to find that. Calls from some coffee. Didn't know you could use wildcards and linker scripts to learn something there. Yeah, that's how you group things into segments. Okay, how hard could it be, right? We just need to port this into Rust. Why did they do that? What is that? Okay, I understand this. I don't understand this. Why do they have that at all? What does that do? I don't know. Why do they call it data lookup? It's looking up a function from the data table 16. Oh. Wait. Huh? Maybe I should be clicking that directly? Let's look. Maybe it's just misquoted, badly misquoted or something. Where is this inline? Oh, that's weird. Okay. I don't get that. Apparently it's in the .h file. There it is. Why? Oh, probably because I see how it, yeah, they're doing this correctly, right? You want to inline this because you're going to call this from RAM. If you don't inline this, you're going to end up calling into Flash, which is going to crash. But the good folks in RPRS didn't do this correctly. They're looking it up using a macro, right? If we go into this, like here, source of that, it's using this ROM functions macro, which is doing this ROM table lookup, right? And I bet ROM table lookup is not inlined. Where's ROM table lookup? There it is. Look, it's not inlined at all. This needs to be marked inline always, right? Well, we can do this. Why don't I just do this? There we go. We're gonna copy it. We're gonna do it ourselves. We'll put and say inline always. Whoops. Inline always. Can I get rid of some of this junk? Hold on. I need this func table thing.
Beep beep.
Copy. Search. Paste. Yeah, okay. Because I'm lazy and I just want to copy paste, I'm just going to do this. So there's the function table. Looks like we need the RAM. We need this other one too. So we have the ROM table lookup pointer, and we have the function table. Well, I don't know what that is. Okay. Why don't we just copy that and inline always also, like they should have done. Line always. What's this ROM FN table? What the heck is this? Tag. Post tickets on GitHub. I can't actually technically do that, Master Agent Miyazaki, but anyone else is welcome to. I'm not really allowed to post anything in GitHub these days. I can look at stuff, that's fine. Okay, anyway, source. It's this ROM functions thing. So, okay, there's going to be... This must be the tag, right? The type of the function. 8-bit, 16-bit, 32-bit, nope. I'm trying to understand what, John, what you're getting at. Or you're not allowed to post to GitHub because at my job I'm not allowed to do any kind of open source. And that includes any kind of contributions, which includes any kind of bug reports. I would need like to get permission for that stuff. I'm just trying to keep things separate between work and hobby. The hobby doesn't do anything that work doesn't allow, you know? So, I should just search for these things, shouldn't I? I see. It's just a way. Got it. I'll just copy these things. There's a code and a lookup. No, I got permission to stream on Twitch as long as it doesn't conflict with work. I didn't get permission to post any code on GitHub or to raise tickets, though. Okay, so was that it? Okay, cool. So then, if those are inlined always, I can look them up. How would I... Okay, back, source... Macros within macros, right? Yeah. I wish people wouldn't do this. Make the code almost unreadable. Really? It's just making a whole bunch of unnecessary trampolines. Ooh, okay, anyway, actually, I can greatly simplify it because none of these take arguments, right? So I can just let me remove all of these ROM data things, right? Actually, we're gonna... Whoops. Get rid of that, and that, and that, and that, and that, but keep those two. Okay. Then let that equal ROM table lookup. Right, so it's a B string, right? No, first is the table. So I can kind of short circuit this, right? I can put that there. Get rid of, well, get rid of tag. I mean table, get rid of table. And then just call it, right? I just need to get the code for it now. All right, we're almost there. IF. It didn't accept that Y. Consider dereferencing. Oh. Fine. Still not the right type. Wait, they want me to dereference it? Wait, what? Okay, what's the type of this then? Unknown. I guess I have to declare its type. Function that returns nothing. Do I need to say that part, or can I just say function? I can just say function. All right. Okay, I'm annoyed, so I'm gonna time you out. For the next 10 minutes, if you want to stick around, that's fine, but please type normally. I don't want to talk, I don't want to read like what looks like it was generated by a program, if that's okay. Okay, I'm gonna do the same thing for these other ones, right? And I'm gonna do that. I need to do them, or I don't need to, but I might as well look them up before I call them, right? Okay. It's almost 1 in the morning. I'm determined to get this working. Okay, exit XIP is EX. Flush cache is FC. And then that one's CX. All right, let's build that sucker. And I want to see the disassembly now. Experiment. Okay. Okay, so here's where it's looking up our 4 functions, right? And here's where it's calling them all. I believe. These ones? Wonder why there's this extra load register there. B0 AC. Yeah, these are... What are these? What's it loading there? Give AI's rights. How about no? Okay, I'm trying to understand why is it loading... Okay, it's loading, but it's doing some kinds of ads and stuff, and then branching. Okay, what's at A8? 4649. It's a weird address to be reading from. Branch with link exchange to... Oh. To what was loaded from that address. Oh, I know what those are. Those aren't addresses. Those are those 2 character codes. These are those 2 character codes that look up the functions. Okay, well, let's give it a try then. I have some confidence that this might work. Oh, it's running. It's working. I fixed it. I fixed it. Okay. Don't panic. We fixed it. It's working. But it's slower now, right? It doesn't seem any slower. It's still running up to 50,000 scans per second. Weird. I expected it to be slower for some reason. But it's not. It is running my code though. How would I verify that? I would verify that by putting a log message here. Flash experiment complete. Bada. Bada. Wait, did I do that in the right sequence? I wasn't paying attention to what I was doing. Okay. That's what happens at 1 in the morning. What happened to my serial port? Why can't it open it? Keyboard's working. I don't know. My putty's lost somehow. But try again. There it is. Flash experiment complete. Okay, it's working. You know what's interesting? I just noticed that there's a 239 millisecond delay between when we first boot up and when we actually get the copyright string out.
Beep beep.
What are we doing in that mid-intermediate time? Oh, setting up the USB stack. That's what we're doing. Huh. So, setting up the USB stack takes 200 milliseconds? I wonder why. I wonder if it hangs and waits for the device to be enumerated. And that's how long it's taking the host to enumerate it. Called it slow XIP in that GitHub thread, but he never said how much slower it actually was. He could have just guessed as far as we know, yeah. So, okay, this is good. That means I can play around with doing flash junk now, right? So one experiment I'd like to do is, before we do this junk, we should read from some flash location, and then in here, I should erase that sector and write, like, that number +1. So every time we reboot, it should increment, and then that will give us true non-volatile storage, right? But I need to pick a sector we're not using. So I happen to know that we can do cargo plus nightly size release and see how big our image is, right? So we're fitting within 64 kilobytes, so I can just like go like 1 megabyte into it, and we're going to be pretty safe. How much RAM do we have, or how much flash do we have? We have 16 megabytes, right? Where does it actually say how much flash we have? Would it be introduction? Here we go. Oh, it's not going to be listed here. It's however much the Adafruit guys added here. So that would be in my other data sheet, the Adafruit one. Flash. How much flash did they put on this thing? Blah, blah, blah. Did they actually not say? Huh. Eight megabyte QSPI flash. All right, so how about we just play it safe and just go only 1 megabyte in? And because I can't remember exactly how much a megabyte is, I'm just going to open my calculator, and I know it's 1024 squared. And hex, so it's 10, it's basically 1 and 5 zeros. So how about we like just dump that out here. Actually, I just do dump, right? I have that function now. The data will be, I can cheat again and look at the original. I can remove that dump that we had in there, right? This thing, and I'll just copy this out and paste it here. We only need to see like 4 bytes of it, but we're going to read from 0x1 0 0 no 1 0 1 0 0 0 whoop, 0 0 0 0, right? So that's 1 megabyte in from the beginning of flash. right? So we're going to dump it out. Then we're going to erase that sector, and then, well, I need to get that value out. How about we just let test address? Well, how about we just give it a real name, counter. I just want to take this address, don't I? And say as mute u32. Just declare a constant. Okay, and then it's going to want me to move that out, which I will. I don't have an FAQ, Romania Hate. How are you doing? What am I doing? Is this thing you're writing the code going to be used for a keyboard? Yeah. Don't you see my 2-key keyboard right here? See, I can press that button and it does a W. And if I can press that button, it does a Q. What more keys do you need? I'll just turn them into copy paste. No, I am doing like a series of experiments in order to have a more complete firmware, because in the end I need to do all these things, right? So the sense keys was the experiment yesterday. We got this running, right? I think I will need to debounce keys because sometimes I see them bounce. And today I was doing this, trying to learn how to write to flash, because it's very cumbersome to program the controllers with the built-in bootloader. I want to be able to like run a program that just programs them, and not only programs the left-hand side of the keyboard, but also the right-hand side too. So like later I'll be doing an experiment where I hook 2 of these controllers up with a serial port or I2C or SPI or something, and then they'll be figuring out how to do the link between the left and right-hand sides. I need to figure out how to do the CAD tool that people use to design the board that all the things are going to go on, and then eventually I'll be doing the mechanical stuff, right? Soldering and all that junk, testing, and then we'll be integrating all that together. Cue the comic where the programmer keyboard just says 0, 1. Yeah, exactly. I actually don't have a command for questions. But there's my notes, which just brings us to here. I don't have a whole lot of notes. I have like, I kept the link to, actually this should be moved to links. Let me do that. Links should have, wait, what's going on? Okay, whatever. Links should have the keyboard scan codes links on it. But the only notes I have so far are what the bits mean in the host report byte. Caps lock is 02 and so forth. Okay, alrighty. This is counter address. Was I going to just do this? I think I'm intended to do this. And then, because then I can put that there. All right, so then I get the counter, and then this is all inside of an unsafe block, so I can just dereference it, right? Counter plus equal 1. No, that's writing back into Flash. I can't do that. Let counter value equal dereference counter, and then add 1 to it. Actually, why do I need to dump this out? I don't really need to do that, right? Yeah, let's not bother with that. Not. Oh, I don't know what I'm thinking. It's late. I want to actually just dump that. Counter. Okay, and then we're going to add the code to actually erase and program. So I need those routines. I need that. Okay, it was back in the boot realm section. Okay, here we go. So I need flash range erase and then flash range program, RE and RP. And we call those between exit and flush. Range erase and range program. This is RE and RP. Okay. These ones take arguments though, so that's going to be a little bit more complicated. Hey, what about Omnia Regnia game? I can't work on that anymore because it's a game, and that's one of the restrictions I have at work, because I can't work on games anymore. KiCad is it good and open source for designing PCBs? I can't remember which one I've seen used. But what I was planning to do is to look at the Korn keyboard and see what format their PWB is in, and what CAD tools people generally use for that. Just looking that stuff up. Okay, I need to change the basically I need this, right? Erase looks, so that's a U32, U size, U32, U8. Okay, and program is that. U32 const, it's star const U8. And then a size, U size. All right. And I'm wondering if I need to mark those as like extern C. I guess I can see what the HAL did. ROM table lookup. What is this? Declare ROM function. Cached pointer? Oh, I see. They don't. Okay, they cached it in RAM somewhere. Yeah. So they only looked it up the first time. Okay, they do have an extern C. All right. So we should do the same thing. I think you can do that. Let's see. Yes. Okay. So basically that is the C calling convention for that. Okay. So here's the dangerous part. It might erase itself, but we can't really break the thing, so no big deal, right? So what do the arguments mean? Okay, the address is from star to flash, so I need 2 of these. Like, there's the counter address, and then there's like counter base. Let's have one versus the other, because we'll have a const flash base or something. Why am I typing when I can copy? Like, let's call it counter like offset. Now we do that, and we'll say counter address is base plus offset. Because when we erase, we're erasing from the counter offset, right? The count is the number of bytes. So we're supposed to be, okay, the address needs to be 4096 byte aligned, which we're doing. Count must be about multiple of 4096, so 4096 it is. And then the next argument is block size. I guess it's 4096. Oh, it's optionally pass a block array. No, what block size? D8H block erase, and the size of the block erase of this command function will use a larger block erase where possible for much higher erase speed. I don't get it. Why do we need to pass anything there? Do I do 0 if it's not optional? Let's look and see what these did. That wasn't, it's not in there. It was in one of these tabs where someone asked about it, right? Right. So, did they ever call erase? No. So this one doesn't have the optional thing. Do I just pass 0? Let's just press 0. When something is optional, generally 0 means don't do anything. So that's what I'm gonna guess. Okay, and then I want to call flash range program. So it's probably again the same offset, right? Maybe not. Address. Oh, there's address and then the data and then the amount. So must be a multiple of 256. Okay. Address must be aligned to a 256 byte boundary. That's no problem. Okay, so then we need to have like data and then 256. Actually, I can do if data is like a slice, then this could be the slice's length. As pointer. So let's make a slice that I guess it could be on the stack, right? Yeah. So let data equal 256. Okay, if we're reading from flash as with a 32-bit pointer, then I kind of want to store back into that as if it was a 32-bit pointer. So let's say dereference and then data, well, the data dot as mute pointer as a pointer to U32, dereference equals counter value +1. Is it not going to let me do that? Can it borrow? Oh, yeah, sure. Mutate it, please. Please do. Please mutate it. So the idea here is we're going to load what's in that, whatever it's in Flash is whatever's there in Flash, and then add 1 to it and store it in the beginning of a slice of an array. And then when we get to programming the Flash, we're going to erase from that offset, not the address, because they want the offset from the beginning of Flash, and then reprogram just from that array. So it's going to erase all 256 bytes and then write the counter value that was there +1 back into it. If I did this right, then every time I reboot it, it should print out, you should add 1 to it. Oops, I accidentally imported something I didn't mean to. Well, I don't know what that is. Okay, here we go.
Ba-da. Ba-da.
Well, it didn't crash completely. So let's see what we printed out. Serial, the putty's missing its window. I have to reset.
Ba-da.
For some reason it's not loading. I don't know what's going on with putty. Okay.
Beep, beep.
Putty's giving me trouble. There it goes. Okay, so counter is 1.
Beep, beep.
All right, and then I reset.
Ba-da. Ba-da.
Why does it say it's not recognized? Oh, it really is not recognized.
Ba-da.
I don't know why it wasn't recognized that time. Oh, now it's 3. See that?
Beep, beep.
And then I reset again. Why is putty, like, sometimes it doesn't open the window? I just hit reboot again.
Ba-da. Ba-da. Ba-da.
Putty's acting up. I'm having to reset the board every time it gets stuck.
Ba-da.
Could that be the code in here? I mean, the USB is obviously working because I can hit keys. But putty, just like I'm running putty, and then it just doesn't. It never opens the window for it. I don't know why. Makes me think I should be writing my own COM port program. I'm gonna quickly look at the device manager. So it says there's a COM12. I don't know why putty can't open it. Oh, there it goes. It just took a long time to open it. But look, it's up to 7 now. So I have a reboot counter now. Interesting. I should remove that dump thing. We don't need that anymore, right? Or if anything, I should just be dumping out the first sector.
Beep.
Let me do that.
Beep, beep.
Okay, so where did I put that dump? Right, so put here counter address. as const u8. Hey, but I think it's working. I'm able to write to Flash and then continue running. So I can actually code up a flasher so I don't have to do the buttons anymore. We now have a persistent reliable memory but transient unreliable PuTTY. Yeah, I think that's going to be one of the next tasks, is because it's so annoying for me to have to run PuTTY. I'm gonna have to make a host side program, probably in Rust, that just automatically latches to the COM port and prints it out. I want it to be able to persist between resetting the keyboard too. So it should just detect if the COM port goes away and comes back. There we go. So it was 8, and then we flashed it with +1, and then we read it back, and it was 9. See that? So I got myself a little bit of a reboot counter permanently in Flash now at 1 megabyte into it. That's cool. I'm going to call the experiment successful, and I'm going to check this in.
Beep, beep.
And then I'm going to go to bed. Do I want to clean this up before I check it in, though? So there's like ugly experimental code in here now. What happened here? I somehow imported GPIO 17? Where am I using that? Oh, right. Because I'm turning that's the GPIO that the LED is on. I was turning that on and off. I don't need to do that anymore, right? So I can remove that. And get rid of the turning it on and turning it on again. I can get rid of this Flash experiment complete because we know it works. What else? We'll keep the Flash experiment itself around. But yeah, I can remove all these things that we don't need anymore. Okay. And this doesn't need to borrow that. And I keep forgetting to do this. I want to rename that WS into NeoPixel. That's what it is. All right. Make sure I didn't break anything.
Ba-da. Ba-da.
See, now PuTTY's has a long pause before opening. I'll let it think while I do the checking comments here. We're using interrupt free again. Oh, because we thought maybe I needed to lock interrupts. I mean, it's probably safe to lock interrupts while we're reflashing anyway, right? Yeah, we're locking interrupts while Flash is being reprogrammed. Keep that. Okay, PuTTY came up. It was 9, now it's 0A, which is 10.
Beep, beep.
I think I'm going to clean this stuff up a little bit before I check it in. I think actually I want to put this into its own file called Flash. Alright, so then mod Flash. Okay, and then all this junk will move to Flash. All right, so this is a public function now. It needs to import some things. All right, so where do I comment and what? Let's put these constants up with the others. Okay, so this is the sector of the Flash where using in Flash Experiment. Is that what I called it? Flash Experiment? I did. Okay, so that comes for 4. This location in the boot ROM holds the address of the boot ROM function lookup table. This location in boot ROM holds the address of the boot ROM I should have copied more. Boot ROM function. Did I get this swapped? That's the helper function. Right. Boot ROM function lookup helper function. So the name is not really that great. Let's fix it. So lookup helper. Let's call it boot ROM lookup helper. This I kind of want to name boot ROM function table. The pointer is redundant, right? We know what the type is. It's a pointer. Okay. This constant is a more useful one. This is the starting address of the flash from the perspective of the ARM microcontroller. This is the sector of the flash we're using in Flash Experiment. Okay. Do I need that? I don't see why I need a special type for that. I can just put that right in there. Okay. I don't like this comment. We'll say this is the type of the boot ROM lookup helper function. Okay. I should use triple slashes to mark them as real comments, right? Okay, so then this, what does this do? This really accesses a half word and then promotes it to a full word. Okay, so this function reads 16 bits from memory and 0 what's the term, like 0 fills, 0 pads it to 32 bits. It's sort of an odd name, so let's call it what's a better name? hold on. I should say reads a 16-bit pointer. Because it's dereferencing, right? Yes. 0 extend. I think it's called extend when you extend it to the left. Okay, so then better name. 0 extend 16 16-bit pointer. That's a better name. So is this more readable now? Okay, I need a comment for this. Let's get rid of this function, so it just says that. Okay. And then this should just say use the boot ROM helper function to find the address of a function of the boot ROM function with the given lookup code, I guess. Or given tag to match the name of the argument there. Hey there, Owen Codes. Pretty good now. I got past a really bad problem. I actually found a bug in this particular crate here in the Cortex M ASM. No, sorry, not this one. In this one, in the RP2040 HAL ROM data, it turns out all of these modules and functions that access boot ROM functions in this microcontroller are not set to be inlined always, so they're dangerous to call, especially the ones that do flash programming. It turns out that they were being linked into the flash, and you can't call a function in flash when you are erasing flash. It was causing bad things to happen. So I basically extracted the code that looks up these functions from the boot ROM from that crate, and I made my own copy with inline always so that it gets put into the RAM where it needs to go. Yeah, and I figured this out by disassembling my built code, and I saw that those functions were being placed in flash and we were jumping to them despite my best efforts. So I have this flash experiment right down here where I purposefully put it in a data section, which the linker script, which I don't have open anymore, but it makes sure it's located, it's loaded into the RAM by the bootloader. So this is all run in RAM, so as long as the things we call are also in RAM, then it's safe to do this erase and program of a flash sector. So it wasn't working until I did my own lookup function, which is all inlined into the RAM along with the experiment. So now it works. So every time I reboot now, it is loading a counter from flash, and when we write it back into the sector, we're adding 1 to it. So it's like a crude boot count right now. It's all connected via Arduino. Well, we're using a Raspberry Pi microcontroller, the RP2040. Same one on the Raspberry Pi Pico, but this particular board is the Adafruit KB2040. So it's meant to be for a keyboard controller, which is what we're going to use it for. So I'm basically going through experiments to make sure we have every area looked into. So the key sense experiment was with these 2 keys, so I can press those 2 keys and they actually do something. And I got a serial port working. We need to do debouncing. I know. So today was getting the flash, figuring out how to write to the flash, because I want to be able to do my own programming, not have to go through the default bootloader, default programmer that this thing comes with. Because to use it, you have to hold down a button while you restart it, and it's sort of a pain. But yeah, I'm doing these step by step so that I can start building up the firmware for the keyboard. And actually, when I get to this where I learn how to use the CAD tool, we'll be actually designing the circuit board for all the switches, diodes, and LEDs, and the controllers, and then we'll have them printed, and then I'll be soldering them together, and then we'll actually have something that resembles a real keyboard like this, right? That's my whole goal. Hey there, MPV0. Seems to be an excellent informative stream. Oh, thank you very much. Don't know how much about low-level programming, learning a lot. How often is the stream? I'm trying to do this Monday, Wednesday, Friday. But it's technically already Tuesday for me, because I'm up really late. So 6 hours a week, 2 hours a day. I've gone way over time tonight because I'm having fun. And I'm planning to also do some YouTube stuff around bare metal programming. So I'm not doing bare metal programming here because we're relying on some libraries that are made by the RPRS people, namely the Cortex M crate. Actually, we don't even need that anymore. Cortex M and MRT, and all the hardware abstraction layer for this board is based off of their work as well. Bare metal programming is pretty hard because bare metal, the definition of that is you have no operating system and you have no libraries, so you have to do everything yourself. Well, you can use what's built into the language. In Rust, it's libcore. So everything that comes with the core of the language you can use, but there's nothing else. There's no setting up memory. There's no talking to any of the hardware. So you have to basically go to a data sheet that comes with your the chips you select, like this, and figure out from what they say how you access stuff. So like you'd be like, how do you use the USB? Okay, you just scroll down and you find where it says USB. And then it talks about the actual registers that you need to access at some point. Yeah, here are the registers, the layout of RAM for different things. Yeah, here's the control register for endpoints, and you have to read and write those memory map registers yourself. Basically, you're writing all your own drivers. I guess an even more extreme level is reverse engineering hardware bare metal, which I tried to do for the Raspberry Pi Zero's USB core because it's not published documentation, and I failed. It is pretty crazy, but in the end, it'd be really cool to have my own keyboard that I can say, I wrote all of the code for it, and it's all in Rust. Thus the Rusty keyboard. Flash experiment is imported from Flash. Oh, I guess we should just replicate. Actually, I can just move that dump in. Yeah, I can just move this to the Flash experiment. After we dump the Flash, we'll just yeah. After we reprogram the Flash, we'll just dump it out again. Just to confirm that it comes back correctly. Oh, an Alex slice, right? I think so, yeah. So I'm just checking in my work and cleaning it up a little bit, but all the stuff here, I had to make my own copy of it because of the bug I found where you have to inline this code, because when you call these things, whether you look them up immediately or they're looked up somewhere else lazily, if you're calling into Flash while you're erasing and programming it, bad things happen. So this is all inlined and linked into a special section that's actually put into the data segment, which is in RAM, to make sure that we can talk to the Flash and not crash. I should make sure that this actually still works, right? Okay, we have an unused import. There. We don't like compiler warnings, and we don't like compiler errors. So until I have my own flasher, I have to use the one that's built into that, which uses UF2. See, the keys work. And serial port should also work. There we go. So our flash counter is up to 10 now, and then we programmed it in and it came back as 11 in hex. And those are the keys. See, as I press and hold down the keys, it's showing the actual key codes. So 20 is Q and 26 is W. I'm also, I got the timer working, so we have a concept of time. We have logging working in general to the serial port, and we actually are tracking the number of scans per second of the keys, which is insane. It's like every 20 microseconds we're able to scan the keys again.
Beep, beep.
All right, checking it in. Unless there's more work to be cleaned up here. I should probably comment what the experiment does. Let's do that. Hold on. Okay. As an experiment, increment a counter in flash located 1 megabyte into the flash so that we don't accidentally erase part of our program. Note. This must execute from RAM, including anything we call. Well, part of this must execute from RAM, including anything at all. So make sure any functions we call within what we call while programming the flash are also in RAM or inlined. And that was the bug we ran into. And I should mark that critical section here. This is the critical section where we must not try to execute from flash because we are programming it. And let me put some cute little markers around this. This is eventually going to be put into the code that I have for actually flashing for real, not just the experiment. And it goes down to there, right? Here we'll just say read back from flash and log it to verify on the console. Okay. This part here, this is look up the addresses of the boot ROM helper functions. We need to program the flash. All right. This is just read our non-volatile counter from flash and prepare an array to write back into flash where the counter is incremented. There we go. So I've commented for future Raimu. All right. Double check main doesn't have anything weird in it. Okay, that got cleaned up. We have the flash experiment imported. I put a comment there. I renamed the NeoPixel. I should mention that in the check-in comment. There's a flash experiment, and I got rid of that dump. And okay, so there's two things. We're doing a flash experiment, and I renamed the NeoPixel. So git commit. The main thing is add flash experiment. Also rename the object representing the NeoPixel LED, well, smart LED. So the main thing was, well, I don't have to repeat it. It's already well commented. All right. Once dated a girl with one leg shorter than the other. I think her name was Eileen. Mr. Balrog, how are you doing? Doing well to get this one. Well done, Mr. Balrog. Eileen? Yeah, I guess you have to pronounce it with the right way, right? The best ones make you think for a bit, and then you start to laugh when you realize what it is. Okay, so I think I'm done for the day, and I might stream tomorrow, but probably not. I'll be back on Wednesday. What I'll probably be doing on Wednesday is I really want to push on this work that I'm doing with the Flash, because I want a nice, convenient way of reprogramming the keyboard without having to press the buttons. I want to do it all from the host through the USB. And then that'll extend naturally when I have the link between controllers. I'll be able to have one board flash the other just by having it do the same interaction, except for instead of going over USB, it'll be going over a TRRS link. So I think, yeah, the Wednesday I'm going to push to write some code that'll do reprogramming. So let's rate somebody, and I hope everybody has a great rest of your day or evening. I'm going to go to bed because I'm tired. It is like almost 2 in the morning for me. I don't see anybody I can raid though. Everybody else has gone to sleep too. You're welcome, Clayman. I hope you had a good time watching and listening. I don't know. I don't really have any ideas to rate. We'll just let you guys pick someone else. All right, I'm just going to end the stream. So, yep. See you guys on Wednesday. Bye-bye.